नमस्कार दोस्तों, मैं और कामेश सर आपके साथ हैं ईडीसी के सॉल्यूशन से डिस्कस करने के लिए। सो क्विकली देख लेते हैं कि ईडीसी बहुत कम क्वेश्चंस आए हुए हैं, 5-6 क्वेश्चंस हैं, तो उनके क्विकली आंसर्स देख लेते हैं। सो लेट अस बिगिन विद द फर्स्ट क्वेश्चन. This question is saying that consider the following statements. So some materials are capable of absorbing energy and then re-emitting visible light in the phenomena called luminescence. अगर आपको याद होगा तो luminescence क्या है? बेसिकली हम लोग एलईडी में जो फिनोमिना पढ़ते हैं वो luminescence ही है, इलेक्ट्रोलुमिनेशंस है। तो luminescence में क्या हो रहा है कि मटीरियल हमारा लाइट इमिट कर रहा है। अब एलईडीज आप जानते हैं विजुअल रेंज की लाइट भी इमिट करते हैं। सो ये स्टेटमेंट तो करेक्ट है। उसके बाद कह रहा है इफ द डिले टाइम बिटवीन एब्जॉर्प्शन एंड री इमिशन इज मच लेस देन 1 सेकंड द फिनोमिना इज टर्म्ड एज फास्फोरेंस। मच लेस देन 1 सेकंड का मतलब यहां पर सिर्फ ये है कि ये फास्ट फिनोमिना है, फास्टर रिस्पांस आपको मिल रहा होगा। थर्ड में कह रहा है कि द डिले टाइम बिटवीन एब्जॉर्प्शन एंड रीमिशन इज मच ग्रेटर देन 1 सेकंड। मच ग्रेटर देन 1 सेकंड का मतलब है डिलेड रिस्पांस है, स्लो फिनोमिना है। द फिनोमिना इज टर्म्ड एज। अब यहां एक चीज आप देखिए, आपसे क्वेश्चन में पूछ रहा है कि व्हिच ऑफ द अबव स्टेटमेंट्स इज नॉट करेक्ट। तो हमें करेक्ट नहीं बताना है, नॉट करेक्ट बताना है। ये स्टेटमेंट करेक्ट है हमारा, सो ये आंसर नहीं हो सकता। सो ये दोनों ऑप्शन तो हमारे कट गए। अब इन दोनों में से चुनना है। तो इफ द डिले टाइम बिटवीन एब्जॉर्प्शन एंड रीमिशन इज मच लेस देन 1 सेकंड द फिनोमिना इज टर्म्ड एज फास्फोरेंस। गलत है। फास्फोरेंस जो होता है हमारा वो डिलेड रिस्पांस होता है, जबकि फ्लोरेसेंस जो होता है वो क्विक रिस्पांस होता है, इमीडिएट रिस्पांस होता है। तो ये दोनों ही गलत हैं। इनफैक्ट अगर इसकी जगह पर फास्फोरेंस लिख दिया जाए और इसकी जगह पर फ्लोरेसेंस लिख दिया जाए तो ये सही हो जाएंगे। सो इसलिए हमारा आंसर जो होगा वो ऑप्शन डी हो जाएगा। नेक्स्ट क्वेश्चन सर आप बताएं।
Okay, so next question is about the carrier lifetime in the semiconductor. Okay, so they are asking for not correct statement. So सबसे पहले तो ये देखना है कि उसने जो पूछा है वो not correct statement के बारे में पूछा है। So the first statement is carrier lifetime ranges from nanosecond to 100 nanosecond. Yes, 100 microsecond we have seen in the many questions. 100 microsecond of lifetime of electron and holes is given. In the nanosecond is also given. So this statement is correct statement. On an average, a holes or electron will exist for tau p second before recombination. Yes, this is the definition of lifetime. Average time spent by the charged particle before recombination is known as lifetime. So B is also correct. Now, C is tau n is the time, lifetime is the time it takes the total concentration to fall to approximately 63% of initial value. So just discuss this point. What is the point is, if suppose some carriers are injected in a semiconductor due to illumination, what we observe, suppose we are having a p-type semiconductor, minority carriers are electrons. Suppose this is a thermal equilibrium concentration of electrons in the p-type semiconductor and this is the decaying concentration of excess charge carrier. So suppose we are denoting delta nt or delta nx we can say. Okay, so in the time domain we are discussing. So delta nt is equal to delta n naught into e to the power of minus t upon lifetime of electrons. We are discussing p-type semiconductor, minority carriers are electrons. Suppose if we put t equal to tau n, then how much excess carrier concentration we will get at t equal to tau n? At t equal to tau n, this will become delta n naught e to the power of minus 1. What is the meaning of that? If we calculate this, we will get 37% of delta n naught. Meaning is that lifetime is the time at which excess carrier concentration become 37% of its initial value or t equal to 0 value. So just see, tau p is the time it takes the injected concentration to fall to approximately 37% of its initial value. Okay, so this statement is correct. Okay, so not correct regarding the lifetime, which is not correct. This is correct, this is correct, the remaining is this. Tau n is the time it takes the total concentration to fall 63%. No, so it is wrong statements. Hence what is the answer of this question is C. C is the answer. So next question will be discussed by Sunil sir. Okay,
At what condition does the Fermi energy level EF lie exactly between the band gap for intrinsic semiconductor? बहुत सिंपल सा क्वेश्चन है। हम लोगों ने मैंने आपको जब भी पढ़ाया तो क्या बताया कि इंट्रिंसिक सेमीकंडक्टर की फर्मी एनर्जी लेवल के लिए एक्सप्रेशन है आपके पास E मिड गैप, ठीक है, प्लस 3/4, मैं डायरेक्टली लिख दे रहा हूं इन टर्म्स ऑफ द इफेक्टिव मास ऑफ इलेक्ट्रॉन एंड होल। सो 3/4 KT ln MP स्टार अपॉन MN स्टार। ये एक्सप्रेशन आप सभी को याद होगा। अगर यहां पर इफेक्टिव मास ऑफ होल और इफेक्टिव मास ऑफ इलेक्ट्रॉन हो जाए तो ये रेशियो 1 हो जाएगा, log 1 की वैल्यू 0 हो जाएगी और EI आपका एग्जैक्टली मिड गैप के बराबर आ जाएगा। सो इंट्रिंसिक फर्मी एनर्जी लेवल मिड गैप पर कब लाई करेगा? जब इफेक्टिव मास ऑफ इलेक्ट्रॉन इज इक्वल टू इफेक्टिव मास ऑफ होल। इसका मतलब क्या हुआ? हमारे लिए ऑप्शंस ढूंढे। द इफेक्टिव मासेस ऑफ अ होल एंड फ्री इलेक्ट्रॉन आर द सेम। फर्स्ट ऑप्शन, आगे कुछ भी पढ़ने लिखने की भी जरूरत नहीं, तो इस क्वेश्चन का आंसर जो हो जाएगा वो ऑप्शन ए होगा। इस क्वेश्चन को रुक जाओ,
Just discuss one second.
because of some technical glitches, let us discuss this question again. मैंने क्या कहा कि इस क्वेश्चन में कह रहा है कि एट व्हाट कंडीशन डज द फर्मी एनर्जी लेवल EF लाई एग्जैक्टली बिटवीन द बैंड गैप ऑफ इंट्रिंसिक सेमीकंडक्टर, यानी इंट्रिंसिक सेमीकंडक्टर में फर्मी एनर्जी लेवल की पोजीशन, दैट इज इंट्रिंसिक फर्मी एनर्जी लेवल। सो इंट्रिंसिक फर्मी लेवल का फार्मूला आप सभी जानते हैं, EI इज इक्वल टू E मिड गैप प्लस 3/4 KT ln MP स्टार अपॉन MN स्टार। MP स्टार इज इफेक्टिव मास ऑफ होल, MN स्टार इज इफेक्टिव मास ऑफ इलेक्ट्रॉन। अगर ये दोनों इक्वल हो जाएं, लेट अस सपोज यू आर हैविंग MP स्टार इज इक्वल टू MN स्टार, तो उस केस में क्या होगा? ये रेशियो 1 हो जाएगा, log 1 की वैल्यू 0 हो जाएगी, ये टर्म पूरा हमारा 0 हो जाएगा। सो जो इंट्रिंसिक फर्मी लेवल होगा वो मिड गैप पर लाई करेगा। ठीक, अब इसके अकॉर्डिंग आंसर ढूंढते हैं। मिड गैप पर कब लाई कर रहा है? जब इफेक्टिव मास ऑफ होल एंड फ्री इलेक्ट्रॉन आर द सेम। इसलिए हमारा आंसर इस क्वेश्चन के लिए क्या हो जाएगा? ऑप्शन ए। ठीक है, let us begin for the next question.
Okay, so now the next questions belongs to MOSFET, FET we can say, FET is MOSFET just, okay, field effect transistor, okay, and BJT. Consider the following statement regarding comparison of FET with BJT. So FET में आप consider कर लो MOSFET को, okay, metal oxide semiconductor field effect transistor. So first statement is BJT is less noisy than FET than MOSFET. It is correct or incorrect? Incorrect statement, because you know very well MOSFETs are thermally more stable compared to BJT bipolar, because in the bipolar case we are having minority charge carrier. When temperature changes, minority charge particle will change and definitely current will change, and stability problem we will get in the case of bipolar, okay, or BJT we can say. So first statement, BJT is less noisy than FET, it is a wrong statement. Second statement, FET is current control device. यहीं पे गलत हो गया भाई। FET मतलब MOSFET is a voltage control device. गेट का वोल्टेज चेंज करते हैं तो इन्वर्जन चार्ज चेंज होते हैं MOSFET में, और करंट को हम कंट्रोल कर सकते हैं। वोल्टेज कंट्रोल मींस गेट वोल्टेज कंट्रोल। सो मीनिंग इज दैट FET is current control? No, it is incorrect. Next, third one is FETs are more temperature stable compared to BJT. Yes, फर्स्ट वाले स्टेटमेंट का उल्टा ही तो है कि भाई टेम्परेचर स्टेबल है। ओके, सो FET या MOSFEट की बात करें तो टेम्परेचर चेंज होने से उनकी करंट में लगभग फर्क नहीं पड़ता है, वैसे करंट डिक्रीज हो जाती है, आपको पता होना चाहिए थोड़ा। सो FETs आर सिंपलर टू फैब्रिकेट एंड ऑक्यूपाई लेस एरिया। अगर मैं इसकी बात करूं तो ये करेक्ट है भाई साहब स्टेटमेंट, बिकॉज अगर हम फैब्रिकेशन पर जाए MOSFEट के और FET के और BJT के, तो आपको पता है BJT लार्ज साइज को ऑक्यूपाई करता है, बिकॉज पैकिंग डेंसिटी आपने पढ़ा होगा, पैकिंग डेंसिटी ऑफ MOSFEट और CMOS इज हाई कंपेयर टू बाइपोलर। तो फोर्थ वन इज करेक्ट। विच ऑफ द फॉलोइंग स्टेटमेंट्स आर करेक्ट? करेक्ट निकालने हैं आपको। थर्ड और फोर्थ करेक्ट है, तो थर्ड और फोर्थ करेक्ट किसमें? सी में। तो सी इज द करेक्ट ऑप्शन फॉर दिस क्वेश्चन। ओके, सी इज करेक्ट।
नेक्स्ट क्वेश्चन कह रहा है कि which of the following is transfer characteristic of NMOS। जरा ध्यान से देखिएगा, NMOS की बात कर रहा है, यानी N चैनल मेटल ऑक्साइड सेमीकंडक्टर। तो अगर NMOS कह रहा है तो बाय डिफॉल्ट हम एनहांसमेंट टाइप MOSFET की बात करेंगे, अदरवाइज वो डिप्लीशन लिखता। ठीक है, सो वी विल नॉट टॉक अबाउट डिप्लीशन। कहीं भी अगर MOS सिर्फ लिख रहा तो बाय डिफॉल्ट एनहांसमेंट टाइप MOSFEट की बात की जाएगी। अब इन चारों में से देखिए कि एनहांसमेंट टाइप के लिए करंट की इक्वेशन कौन सी है। देखो, ये इक्वेशन जो है वो JFET और डिप्लीशन टाइप MOSFEट के लिए है। तो गलती से पहला ऑप्शन तो वैसे भी अगर एग्जाम में ऑप्शन ए रहे तो उसको रीचेक करना चाहिए कि कहीं बेवकूफ बनाने के लिए तो नहीं दे रहा है। तो पहला ऑप्शन ये JFET और डिप्लीशन टाइप MOSFET के लिए सही है, लेकिन हमसे क्या कर रहा है NMOS, हम बाय डिफॉल्ट एनहांसमेंट लेकर के चलेंगे। ठीक है, ये तो गलत है, ऐसी कोई इक्वेशन होती ही नहीं हमारे पास। ठीक, अब यहां देखिए NMOS लिखा हुआ है तो BGS माइनस BT, ठीक है, ID K BGS माइनस BT का होल स्क्वायर, यही आपका सही इक्वेशन है। इसमें कुछ भी समझाने के लिए नहीं, डायरेक्ट आपको ये फार्मूला याद रहता है कि आपका क्या हो जाएगा, कंडक्शन पैरामीटर हो जाएगा, जिसके लिए अब मैं जनरली जो आपको लिखाता हूं वो μ1/2 μ1 C ox W/L के टर्म में, तो उसी को इसने K लिख दिया है। ठीक है,
तो इसमें एक और चीज आप नोटिस करोगे, ट्रांसफर कैरेक्टरिस्टिक्स के बारे में बोला है उसने, तो आपकी ट्रांसफर कैरेक्टरिस्टिक्स भी इसी इक्वेशन के थ्रू बनती है। ओके, सो नो प्रॉब्लम।
हाँ, ट्रांसफर वर्ड जहां भी रहा है उसका मतलब आपको आउटपुट और इनपुट के बीच में रिलेशनशिप चाहिए। अब मॉसफेट में इनपुट क्या होता है, हमारा गेट वोल्टेज, ठीक है, और आउटपुट क्या ले रहे हैं, ड्रेन करंट, तो आउटपुट वर्सेस इनपुट, दैट इज ट्रांसफर कैरेक्टरिस्टिक।
Okay, so now next question is which one of the following statement is correct for n channel or p channel MOSFET? Meaning is that चाहे n channel MOSFET कंसीडर कर लो या p channel कंसीडर कर लो, और फिर आप कंपेरिजन करो JFET से, और कुछ ऑप्शंस दिए हुए हैं उसमें देखते हैं अपन। पहला है ड्रेन रेजिस्टेंस ऑफ MOSFET इज वेरी लार्जर देन JFET, चलो बाद में देखेंगे इसको। चलो बी पे चलते हैं, बी को बाद में देखेंगे। सी को देखते हैं पहले, इनपुट रेजिस्टेंस एंड फीडबैक रेजिस्टेंस। अरे फीडबैक कैसे आ गया, एनालॉग है ना, तो अपन चलो इसको ही एक इनपुट रेजिस्टेंस वाले टर्म से अब चेक कर लें हम, तो हमें समझ में आ जाएगा, क्योंकि सर्किट तुम्हारे पास है नहीं। तो इनपुट रेजिस्टेंस आर वेरी स्मॉलर देन JFET, मतलब ये क्वेश्चन में बोल रहा है कि MOSFET ले लो n चैनल या p चैनल, उसका इनपुट इंपीडेंस JFET से कम होता है क्या? अगर आप करेक्ट रिलेशन देखें, आप अगर इनपुट इंपीडेंस को मैं RI से डिनोट कर दूं, तो आपको पता है कि MOSFET या FETs का बात करूं मैं, ओके, MOSFET का, है ना, कंपेयर टू JFET के कंपेरिजन में इनपुट इंपीडेंस MOSFET का ज्यादा होता है, ये तो पता है आपको, क्योंकि JFET में तो एक रिवर्स वाइज पीएन जंक्शन है, MOSFET में ऑक्साइड है भाई साहब, ठीक है। तो RI इज ग्रेटर देन RI ऑफ JFET, और मच ग्रेटर देन भी बोल सकते हैं हम। तो डेफिनेटली ये ऑप्शन जो है आपका वो रॉन्ग हो गया, क्योंकि इनपुट इंपीडेंस को वो स्मॉलर बोल रहा है कंपेयर टू JFET। ओके, इनपुट रेजिस्टेंस एंड फीडबैक रेजिस्टेंस आर कंपेरेबल टू JFET, के कंपेरेबल दिख रहे हैं क्या? ये बिल्कुल रिवर्स वाइज पीएन जंक्शन है और यहाँ पर ऑक्साइड जैसी करंट जीरो है, तो अगेन दिस स्टेटमेंट इज रॉन्ग। अब ए पर चलते हैं, ए पर चलें तो ड्रेन रेजिस्टेंस दैट इज द आउटपुट रेजिस्टेंस ऑफ JFET एंड MOSFET। अगर हम आउटपुट रेजिस्टेंस की बात करें, आउटपुट रेजिस्टेंस या ड्रेन रेजिस्टेंस, तो जो JFET का होता है वो ज्यादा होता है कंपेयर टू आपका क्या, MOSFET। अगर आप चैनल लेंथ मॉड्यूलेशन इफेक्ट की बात करें और स्लोप ऑफ द कैरेक्टरिस्टिक्स देखें, तो वो स्लोप ऑफ द कैरेक्टरिस्टिक्स अगर आप ऑब्जर्व करोगे तो JFET के केस में कम दिख रहा होगा और MOSFET के केस में आपको ज्यादा दिख रहा होगा, मतलब JFET का R0 या RD ज्यादा होता है कंपेयर टू MOSFET। ओके, सो ड्रेन रेजिस्टेंस ऑफ MOSFET इज वेरी लार्जर देन JFET, अगेन इट इज रॉन्ग। अगर हम बी पे चलें, तो अब ये बेटा ये जो क्वेश्चन बोल रहा है ना, वो n चैनल एंड p चैनल के लिए बोल रहा है। तीन में तो उसने कंपेयर करा दिया JFET से, तीन ऑप्शंस में A, C एंड D में। बी में वो अपने आपस में क्या कर रहा है, कंपेरिजन कर रहा है, किसको, n चैनल MOSFET को, p चैनल MOSFET को। ट्रांस कंडक्टेंस एंड इंटर इलेक्ट्रोड कैपेसिटेंसेज have comparable values for the two types of device. Which two types? n channel MOSFET and p channel MOSFET। अगर हम बात करें n चैनल और p चैनल का, अगर मैं GM देखूं nMOS का और pMOS का, लगभग क्या आएगा, अप्रोक्सीमेटली सेम आएगा कि नहीं आएगा? भैया क्या अंतर होता है, केवल और केवल करंट का अंतर होता है, मोबिलिटी ऑफ चार्ज पार्टिकल का अंतर होता है। सो डेफिनेटली एग्जैक्टली सेम नहीं होंगे, बट वो अप्रोक्सीमेटली बोल रहा है। तो बेस्ड ऑन द ऑप्शंस वी हैव टू गिव द आंसर। तो बेस्ड ऑन द ऑप्शंस इट इज करेक्ट आंसर। ट्रांस कंडक्टेंस आर सिमिलर। एंड कैपेसिटेंस की बात करें हम, तो कैपेसिटेंस क्या होता है, ऑक्साइड का कैपेसिटेंस। तो पीमोस ले लो या एनमोस ले लो, ऑक्साइड की थिकनेस पर ही डिपेंड कर रहा होगा, एप्सिलॉन A बाय ऑक्साइड थिकनेस। ओके, सो दे आर कंपेरेबल। सो बी इज द करेक्ट आंसर फॉर दिस क्वेश्चन। ओके,
सो आई थिंक EDC में हम लोगों के पास इतने ही क्वेश्चन थे, तो EDC के लिए बस जो भी क्वेश्चन थे बहुत सिंपल थे, बहुत थोड़े से क्वेश्चन थे, तो EDC का डिस्कशन होगा। अगली सब्जेक्ट का डिस्कशन करने के लिए आपके अदर फैकल्टी मेंबर्स आएंगे, और सर दोबारा एडवांस इलेक्ट्रॉनिक्स में थोड़ी देर बाद आपसे मिलेंगे, और मैं मटीरियल साइंस में आपसे दोबारा मिलूंगा, लेकिन थोड़ी देर बाद। तब तक दूसरी सब्जेक्ट पढ़िए। थैंक यू।
Good evening, dear students. I'm Iftikhar Ahmed and my colleague Rajkumar sir. We
Good
both
evening.
will be discussing the solutions for analog electronics. We have totally 6 questions from analog circuits. I will go through first 2 questions. This question is about the definition of dynamic resistance. Right? What is meant by dynamic resistance of a diode? Now, if you remember the diode basics, in the dynamic resistance, we calculate dynamic resistance from the VI characteristics, right? This is the VI plot for a diode, exponential curve, and we calculate dynamic resistance at the operating point. Let us say this is the operating point, Q point of the diode, some voltage V and current I. Then to find dynamic resistance, we have to consider slope of the tangent at operating point. Let us say this is a tangent at the operating point, then that slope will be di upon dv, and if you take reciprocal of the slope, that reciprocal will be called the dynamic resistance of a diode or AC resistance of a diode. So in this way we obtain dynamic resistance from slope of the tangent. Now if you look at the options, option B says it is a tangent line at the Q point in graphical determination. So we have to find slope of the tangent at the operating point and take reciprocal of that slope. That reciprocal will give us the dynamic resistance. So in this way the correct answer for this question should be option B. Option B should be correct for this particular question. Let us move to the next question. The next question is about stability factor. Now we know well from BJT that in a BJT collector current is unstable because of variation in ICO, VB and beta. Now change in IC with respect to ICO will be measured in terms of stability factor S. So if you remember your BJT basics, stability factor S is defined as rate of change of IC with respect to ICO. So in this way the correct option for this question should be option A, change in IC divided by change in ICO. So that is your answer, option A. Then my colleague Rajkumar sir will discuss the next question.
Thank you very much, sir. Thank you. The next question. The next question is which of the following statement is not correct for H parameter values of the transistor? I don't want to discuss all the options here. I understood that B will be the correct answer for this question. B. Why? Because the output conductance is low in case of common emitter, he said, common emitter and common collector, as compared to a common base configuration. That is looking wrong answer, because we know that HOC is equal to HOE. HOC and HOE are equal, okay, but HOB, when you are writing conversion, which is HOE by 1 plus HFE. Generally, who is studying hybrid parameters, this conversion formulas most probably most of the students will learn. So I am expecting the answer will be B, because the statement he has given wrong answer, okay. Common emitter will not have low, common base will have the low impedance. The next question, a circuit amplifies, what is this question? A circuit that amplifies the difference between two signals is called. Straightforward definition he has asked. A differential amplifier definition it is. It amplifies a difference between two signals. Everybody has sent two inputs for an op amp. Inside we have a differential amplifier. So straightforward answer. So option A will be the correct answer for this. So the other two remaining questions, Iftikhar sir will take. Thank you. Yeah.
Thank you, Rajkumar sir. The next question is about Schmidt trigger, which comes under positive feedback applications of op amp. This question is about which of the following is correct with respect to Schmidt trigger. Now we know very well that Schmidt trigger provides square wave output. Whatever input you apply, sine wave, triangular wave, etc. to a Schmidt trigger, it will convert that into a square wave output. So in that way, Schmidt trigger can be considered like a square wave generator. And then Schmidt trigger is a comparator circuit having positive feedback. we also call Schmidt trigger as a regenerative comparator. Okay, Schmidt trigger is also called regenerative comparator because it is a comparator having positive feedback. So in that way it can be considered as a comparator also. Whereas astable multivibrator, that is a different circuit. Astable multivibrator will be formed by connecting one more RC network in the Schmidt trigger. So Schmidt trigger cannot be called astable multivibrator, but Schmidt trigger can be considered as square wave generator and comparator. So 1 and 2 are correct, and therefore the correct answer should be option B. Option B is correct here.
Yeah.
1 and 2 are the correct properties
Answer.
of Schmidt trigger.
Yeah.
Then we have one more question, which is about an astable multivibrator using 555 timer IC. Now in this astable multivibrator, we have to do calculations for the T1. T1 is nothing but low interval where output is low. T2 will be interval where output is high, and we have to find frequency of the output. We have to calculate even duty cycle of the output waveform. It is a formula based question. If you know the formula for T1 is actually here low interval, and that low interval formula is 0.69 into RB into C. Okay, 0.69 into RB into C. That RB resistance is 10 kilo ohm here, and capacitance is given 680 picofarad. If you substitute these values, you will get T1 as approximately equal to 4.7 microseconds. Okay, T1 or low interval is about 4.7 microseconds. Then we have to find even T2. Let me write here itself T2. T2 is nothing but the high interval where output is high, and T high formula is 0.69 into RA plus RB into C. These are standard formulae which we know from the 555 timer topic. Here you substitute RA 4.7 kilo ohms and RB 10 kilo ohms and capacitance 680 picofarad. And if you calculate this, it will be approximately equal to 6.9 microseconds. Okay, so these are the high and low intervals, 4.7 microsecond and 6.9 microsecond. Now if you add these two intervals, then we get time period. Let me write here T0 is equal to T1 plus T2. If you add these two values, 6.9 plus 4.7, it will become about 11.6. It will come out as 11.6 microseconds. Then we should take reciprocal of the time period. That will give us frequency F0 equal to 1 upon T0. And when we take reciprocal of the time period, the frequency comes out as approximately 86 kilohertz. 86 kilohertz approximately.
Yeah.
I think this much will be enough to decide the answer. But we will calculate duty cycle also. A duty cycle is defined as, if I write percentage duty cycle, it will be T high divided by T0 into 100. This is the definition of duty cycle, duration for which output is logic high divided by time period. Now if you substitute here T high 6.9 microseconds and total time period 11.6 microseconds and multiplied with 100, it comes out as approximately 60%. So this question has about 4 calculations. If you do all these calculations, you will get the answer, and the correct answer should be option A. For this particular question, answer is option A. So these were the 6 questions from analog electronics. And Rajkumar sir,
These questions are looking very easy and comfortable. There is no straightforward questions. Iftikhar sir, they are all straightforward questions. Okay, next.
Thank you guys. Next subject
will continue. Thank you.
the ESE exam. So before going to start about the solutions, so totally we have 4 questions appear from the signals and systems. So first question, which of the following statements is correct for the given system? So y of n is equal to x square of n plus 1 by x square of n minus 1 is the value we are having. If you see this question, you are asking the system is linear, non-causal and shift invariant. The given system is non-linear, causal and shift invariant. And next one is the given system is non-linear, causal and shift variant. The given system is linear, non-causal and shift variant. Shift invariant he was asking. If you see the question, very simply we can tell such that by seeing this square terms, it is definitely going to be a non-linear. Because of the square terms, we can tell it is non-linear. And as usual, if you see about the next one, he was asking about the shift invariant, n and n. If you put delay in the input x of n minus n naught, the input is delayed, and in the delay in the input value we can find out like this, that is y of n is x square of n plus 1 by x square of n minus 1. So delay in the input. So delay in input. When you make delay in the input, so y of n is equal to x square of n minus n naught plus 1 upon x square of n minus n naught minus 1. Next step what we are doing is delay in output. It's a direct question. So delay in the output means you can put n is equal to n minus n naught in y of n. When you put n is equal to n minus n naught in y of n, the value is equal to that of x square of n minus n naught. See, wherever we have n, we are just substituting n minus n naught, then plus 1 upon x square of n minus n naught minus 1. So both are same. System is said to be called as shift invariant. Because the shift invariant we are having, because both are same. So that's a shift invariant we are having. Next one is causal. So same instant of time. So we can tell definitely being a causal. System is causal. It depends upon the present value and on the past values, but not on the future values. So therefore we can substitute those values. So we can tell clearly such that the y of n, right, in the given expression for causal. So if you see the causal, you can tell y of n is equal to x square of n plus 1 by x square of n minus 1. If you put n is equal to 0, so y of 0 is equal to x square of 0 plus 1 upon x square of minus 1. So this is the present output, and you can tell that this is the present input and this acts as the past input. So now if you see the system is depending only on the present input and on the past inputs, but not on the future values. So we can tell very clearly such that system is becoming as a causal. So if you see the options, that means it becomes as a non-linear. By the first time it became as a non-linear, and now it become as a shift invariant, and it become as a causal. If you check the options, so see the options, that is whenever you are checking the options, so the given system is a non-linear and it is going to be causal and shift invariant. So then the answer is nothing but an B. So I think most of the students has put the same answer as B. That's the answer we are having for question 88. So next question, if you see the next question, so if the impulse response h of n and the output y of n of a system are given as, so h of n is equal to 2 comma 1 comma 0 comma minus 1 comma 3, and y of n is equal to 2 comma minus 5 comma 1 comma 1 comma 6 comma minus 11 comma 6 is given. So we can solve this question in 2 ways. Then the input x of n of the system is, I was asking about that. Use the deconvolution method of a system identification or system identification, or you can solve it by using your jet transform also to get the required values. Okay. Now we know that for a given system, we can write like this. So giving the solution, so we can write that y of n is equal to x of n convolved with h of n. It is given h of n. So once we write about this value, we can apply the Z transform. Then y of z is equal to x of z, because convolution in one domain will become equal to multiplication in the another domain. That we want x of n, that means I will write like this: x of z is equal to y of z divided by h of z. So given that h of n, if you see the h of n is given as 2 comma 1 comma 0 comma minus 1 comma 3. Here the value is given, h of n value. So therefore we are trying to writing about the h of z for this one, that is h of n is given as the series. So 2 comma 1 comma 0. Then we can write about the h of z for that one, that is given as h of z is equal to 2 plus 1 into z to the power of minus 1, so plus 0 into z to the power of minus 2 plus minus 1 into z to the power of minus 3 plus 3 into z to the power of minus 4. And similarly for y of z also we can write from the given y of n data. So we can write about the given data, that is from y of n. So we can write like this: y of n, that is equal to y of n. Y of n is equal to 2 comma minus 5 comma 1 comma 1 comma 6 comma minus 11 comma 6, it is present. Then if you apply the z transform, become y of z, that is 2. So minus 5 into z to the power of minus 1 plus z to the power of minus 2 plus z to the power of minus 3 plus 6 into z to the power of minus 4 minus 11 into z to the power of minus 5 plus 6 into z to the power of minus 6 is the value we are having. Now we can substitute that. So both, so x of z, that is equal to y of z, that is equal to 2 minus 5 z to the power of minus 1 plus z to the power of minus 2 plus z to the power of minus 3 plus 6 z to the power of minus 4 minus 11 z to the power of minus 5 plus 6 z to the power of minus 6 whole divided by h of z, that is equal to 2 plus z to the power of minus 1 minus z to the power of minus 3 plus 3 into z to the power of minus 4. So after substituting this, we need to convert that, then the leftover value is equal to that of so x of z value was going to be equal to, if you write the x of z, that is equal to that of 1 minus, the value is equal to 3 z inverse plus, so 1 minus 3 z inverse plus 2 z to the power of minus 2 is the value left over by solving this entire one, x of z. So then apply inverse z transform. So when you apply inverse z transform, so when you apply the inverse z transform, then x of n is nothing but an 1 comma minus 3 comma 2 is the value we are having. So 1 comma minus 3 comma 2 is the value we are getting. So if you see that one, check for the options, that option x of n is equal to 1 comma minus 3 comma 2 is nothing but an option A, equal to option A we are having. So this was the second question. So coming to the next one, if you see that he was asking the DSP, digital signal processing. So the approximate transition width of main lobe in Blackman window. As you see about the windows in FIR filters, the width of the Blackman window, it's a standard question, theoretical value, that is equal to 12 pi by n is the width of the main lobe in Blackman window. So next question, if you see about the next one, consider the following statements regarding the filters. So I told you the last two questions are asked from the DSP. So this one, Core filter has equiripple passband and stopband. The specialty of Core filter is that only, which consists of both the equifilter equiripple passband and stopband is present. Both equiripple passband and stopbands are present if you see about the Coil filter. And next one is for a given filter, that is the first one. The statement is following regarding filters. So which of the above statements are correct, he was asking. So this statement is the correct statement we are having. That is Coil filter has equiripple passband and stopband. If you see about the next one, for a given filter order, passband and stopband deviations, Coil filter have more transition bandwidth as compared to Chebyshev filters. Actually, if you see about the statement, the Coil filter and Chebyshev filters, if you compare the two filters, this one is going to be not a correct. It's not more. Actually, it is going to be having that less transition bandwidth as compared to Chebyshev filters we are having. Okay, so that's what the statement. So two statement is wrong. So linear phase characteristics cannot be achieved in IR filters. It's true. If you see about the IR filters, they are designed with respect to the magnitude response. But when you see about the FIR filters, they are designed completely with respect to the linear phase response. That means you observed clearly such that here linear phase characteristics cannot be achieved. Means that is true only. Linear phase achieved with FIR cannot be achieved with IIR. That means this statement is also true. So do you find out that from the given three statements, two statements are correct? That means 1 and 3 are correct. So option B is the correct answer. So option B is the correct answer. So these are direct statements that ask without any numericals. They ask from the filters, from DSP, digital signal processing. So all the questions, most the models and most of the questions that come from the class notes and as well as the test series of MEDISE. Okay. So the next subject they will discuss about the remaining questions. Thank you.
Hello students, welcome to the digital electronics session. Here in the AC branch, digital electronics questions this year asked was very easy questions, you can see that. And in these questions, you can answer also these questions so joyfully also. And let me consider one by one the questions here. Of course, while I am explaining itself, you may get the answers like that because these are very easy questions. Let me check these questions. Now here, if you observe, this is the question here where decimal number of 396 and they asked the equivalency of in binary, gray and XS3. As you know, in the binary it is so simple, you know that, and in the case of gray, how we can make the conversion and all, we can check that thing also. As you know, binary to gray conversion, in that the procedure is, you can see now with this example. First of all, 396 for that one, 396 for that one, the binary I will take, and from that I made the conversion into the gray. Okay, right. First of all, 396 for that one. What is the binary of that? For example, if we take that, we will have that one is nothing but binary of 396 is 1 1 0 0 0 1 1 0 0. You check, have you got the same thing like that here? You will have 1 1 0 0 0 1 1 0 0. So this one, to get the gray conversion, it is so easy thing. How? This MSB should be written as it is here, this should be written as it is here, and for the next bit these two should be taken as exclusive OR operation, that means the sum. As you know, the sum is based on the XOR gate only. We are going to do the arithmetic sum operation, we know that. Generally students used to have a doubt about, sir, OR operation is there no for sum? No. OR is the logical sum, but XOR is going to give the arithmetic sum. Okay, so based on that, if you check, this one MSB is as it is here, we have to get, and next 1 plus 1, that is nothing but we are going to have, this is the sum is 0, carry we have to leave that, and here again 1 plus 0, it is going to give, this is the 1, and here 0 plus 0, we are going to have the 0 here. You check here, I am just keeping the symbol of XOR because arithmetic sum is going to be done by the XOR, no, that's why I already said that thing. Now here, this is going to be like this, here it is 0, and 0 plus 1 is nothing but here 1, and 1 plus 1, sum is 0, carry is 1, we are not considering the carry here, okay, right. And here this 1 plus 0, it is going to give the 1, and 0 plus 0, it is going to give the 0. You please check here one time, all of you. Have you got this one? 101, 001, 010. So this is the way we are going to have the conversion of binary to gray, where MSB is taken as it is, and for the next bit, that bit and the previous bit has to be taken as arithmetic sum, and based on that the result is 1 plus 1, sum is 0, carry we are just leaving like that, and next for this next bit, that corresponding bit and the previous bit should be taken the addition, again the XOR operation like arithmetic sum, and we are taking the result. In that manner we are going to get. So this is nothing but the process of binary to gray. So then you can check the options based on this, okay, right. And if you come to the next question here, this is on the Boolean expression given, f of ABC is the function a bar BC plus AB bar C plus ABC bar plus ABC. Actually, if you are having the idea about the carry of a full adder, simply we can say based on that the result here. But anyway, even though you are not able to remember all those things also, simply we can solve this one by applying the K-map. Yeah, for that one, let me consider here K-map. Yeah, this is the way, 3 variable K-map we are taking here. As you know, this is A bar A, and here it is B bar C bar, B bar C, B C, B C bar. And inside the cell, the numbers, you know that all our students know, when MSB is represented here, MSB notation is la 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 la, like that we are going to make it, you know that thing. That means it is nothing but 0, 1, 3, 2, 4, 5, 7, 6. Okay. Now in this one, if you make A bar BC representation here, yeah, A bar BC, this is A bar BC, and next A B bar C, A B bar C, next A B C bar, A B C bar, next A B C, this is A B C, and just if you make the K-map for that simplification, we can have, this is nothing but like this, and like this we are having. So for this one, you know that this is nothing but we will have AB plus BC plus AC. So this is the thing. So based on that, you can check the result here. This is actually the carry of a full adder. That is only the result we are getting here. So but even though you are not able to remember that, by the K-map also you can simply solve it. Got it, no? So this is about this question. Like that the questions actually given so simple questions, and that too these are not time taking also. Very simply in the less time also are able to answer these, like that the questions they gave. Really a scoring thing like that, no it is. Now we will check this question also here. Here to solve this one, simply do one thing. This bubble, first we cancel it. Yeah, we can cancel, no, those two are here. Now a plus a bar we are going to have here, a plus a bar, which is nothing but 1. So here we are having the input as 1, and for this AND gate this is AB bar, so that we are going to have here this is AB bar, no, like that. And for this one we can say this is AB, and as you know this is not gate, so that is AB bar whole bar. So here the expression is going to be AB bar plus AB whole bar, like that. So here this one if you check it, options are going to be AB bar plus AB whole bar is there, and if you are going to have the simplification of this one, finally what we are going to get is, you check this one, AB bar plus this is A bar plus B bar, and if you take in this one B bar as common, we can have that one, finally it is going to give the result of A bar plus B bar. So simply we can get this one. For this one no logic is required, very simply the question is actually asked, no, here. So like this we can make the solution of this question. Actually logically and challengingly to do in the digital, this year nothing is given. All these are so simple way to solve. That is the way they give the questions here, is it not? That's why I said it is a scoring the digital, right? Next here, if you come to this point of next question, yeah, this is somewhat a good question, as you know, but it is also so simply given. Here you see A, B and C in. C in is carry input, or the 3 inputs of a full adder of a circuit. D0 to D7 are the inputs of 8/1 multiplexer. Here 8/1 multiplexer they want to use for the representation of this particular full adder. That too not all the things asked in that. They asked so simply, you check here, to implement the expression of sum of the full adder. That means they asked here sum of the full adder only. Using this multiplexer of 8/1, connections of the input ports and selection lines should be what they asked. Very simple, no? That too only the sum expression is asked. First of all, we will take the expression of the sum of the full adder. As you know, sum of the full adder is nothing but sigma small m 1, 2, 4, 7. Sir, how it will be 1, 2, 4, 7? Array, it is so simple, no? Check it, how it is going to be. Let me say that, okay? Yeah. For this one, let me check it. Yeah. Full adder for that one, this is A, B, C in, if you consider 4, 0, 4, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and here we are having so simply 0, 1, 2, 3, 4, 5, 6, 7. These are the possible combinations. And for the sum, the result will be what here? It is going to give the 0, it is going to give the 1, and it is going to give the 1, and it is going to be like 0 plus 1 is 1, 1 plus 1 is, sum is 0, carry is 1. But we are focusing only on the sum. Why? Because in the question they asked only about the sum expression only, no? To implement the sum expression with the help of multiplexer. That's why we are taking the sum only here. That's why I am writing here, it is going to be 0, and it is going to be 1, and here 1 plus 1, sum is going to be here 0, and here it is also 0, here it is 1. Sir, how it is 1 here? Why not? 1 plus 1 is 0, carry is 1, but for that 0 again we are adding the 1, no? That's why we are going to get the sum as 1. So like that. Now tell me what the numbers we are having here for this, and here and here. That means what? 1, 2, 4, 7. So the sum expression is nothing but we can say sigma small m 1, 2, 4, 7. Now it is clear. Without drawing the picture also we can get that. Because the inputs of 1, 2, 4, 7 has to be 1 and the remaining has to be 0. Let me check that. Let me draw that. Okay. Here this is the 8 by 1 multiplexer. With the select lines, this is A, B, this is C. We are having here 1, 2, 3, 4, 5, 6, 7, 8. That means we can have this is D0, D1, D2, D3, D4, D5, D6, D7. And this is nothing but the 8 by 1 multiplexer. I think now you understood already. Because here 1, 2, 4, 7 has to be 1. Isn't it? So here this 1, 2, 4, 7 has to be 1 and remaining should be 0. That's enough. And these are nothing but what they gave. No, in the question, let me check that in the question here. In the question they mentioned that, yeah, S2 is MSB, S1 S0, where S0 is LSB. So that based on that simply we can say here S2, S1, S0. So now check these based on that the options, we can easily get the answer for this one also. It is also so simply directly you can get it. Actually this one with the help of 4 by 1 marks to do, that can be a challenging question. That can be not a challenging, logical question, you can feel like that. But they ask it simply by 8 by 1 marks only. So a direct question like that, no, that is the answer for this question. You can solve in this manner. I think you got it, isn't it? Right. Next we will see that, like that. Yeah. This is here asynchronous counter they give, asynchronous counter. Okay. In the case of asynchronous counter, how many flip-flops here you check it here? 1, 2, 3, 4, 5 flip-flops given. As you know, in the case of asynchronous flip-flop, we are going to use the toggle mode flip-flop, T flip-flop, no? Sir, but they gave the JK flip-flops, no, here. Array, into JK flip-flop used in the form of T flip-flop only, no? JK together connected to the high. Plus 5 means, that means it is nothing but we are applying that one as the high JK together connected and apply to the 1 means we can say that is used in the form of toggle mode operation only. And a T flip-flop always divides the frequency by 2, isn't it? Sir, by 2 how it is? Yeah, let me check that. It is so simple, that is also okay. Let me consider for example one particular T flip-flop. Here J, K, these two are together connected and connected to the high. So here it is Q and here it is Q bar, as you know, and here we are applying the clock here. Okay, clock. Initially, for example, 0 is present initially. Okay. Now, if you apply one clock, as you know, T flip-flop operation is, it is going to make toggle mode. That means previously if it is 0, it will give the 1. Previously if it is 1, it is going to give the 0. That thing you know very well. So here previously it is 0 and now we are applying one clock here, so that it is going to change as 1. Okay, sir. Then if we apply another clock pulse and again toggle, this one going to become as 0. That means here 2 clock pulses we applied, but here we got only 1 clock pulse. That means input frequency if it is x hertz, input frequency if it is x hertz, output frequency is actually what we can say is x by 2 hertz. Because input time period t, here it is actually 2t we got, no? That's why we are getting the x by 2 the frequency division. So, one T flip flop when it is making the division of by 2 half of the input frequency, then that is going to be divided in such a way that x by 2, then it is going to be x by 4, then it is going to be x by 8, then it is going to be x by 16, then it is going to be x by 32. So easily we can get the answer for this one. You check it here, how it is going to be here. X hertz here, if it is here, it is x by 2, and here it is x by 4, here it is x by 16, x by 8, here it is x by 16, and here it is x by 32. So, by 2, by 4, by 8, by 16, by 32. So, based on the 22.4 megahertz by that particular division of frequency, x is here 22.4 megahertz, by 32 by making the division, you will get the answer so easily for this one also, isn't it? 700 kilohertz easily you will get that for that. Got it? Right. And next we will see like that only the questions here. This Boolean expression can be solved so simply by just making the De Morgan law, applying like that. Simply we can get the simplification of this one. You can try this one, a plus b. Yeah, you can get the simplification of that, a plus b dot c bar d bar plus e plus f bar, and this entire thing is whole bar. So, just by making the De Morgan law, a plus b dot c bar dot d bar, here dot e plus f bar, here this is the bar, and bar, this plus is became as dot. Like that, if you make this like that only, making the De Morgan law, simply you can get the answer of that one, isn't it? This one, like you check this one, what is the answer that you are getting here for this one? Because after the simplification of that one, so simply we are going to get, okay, like that the simple questions only they asked here. Got it? Now, there is one more question also, like here they gave, I think here, yeah, this is the n bit numbers AB can be carried out using the n consecutive arrangement like that. As you know here, number of full adders are connected in a cascaded manner, then that is going to be ripple carry adder, and that is a direct question. That's why I just wonder like how simply they asked the questions. No need to apply so much logical thinking also here, and less time you can answer very well easily also. I think you enjoyed the digital questions in the exam, isn't it? Thank you so much for this session, right? Okay.
Hello students, after long time, after a great struggle of preparation, this day is a deciding day for you, how you have performed. Fine, let us discuss the questions regarding, I am Vijay Kumar, so let us discuss the questions regarding the microprocessor and microcontrollers which were given for the ENT paper, Electronics and Telecommunication paper for ESE exam, right. So, there were about the analysis of the paper, there were 5 questions given, among which one is a numerical and other 4 are like theory type of questions, but one of the question was involved with some numerical type also, which is related to the theory, right. Let us discuss the questions in a elaborate way so that you can understand how that can be cracked off. Fine.
Right. So the first question which was given is question number 85. Consider the following statements regarding the programmable interrupt controller. It is also called as PIC 8259A IC. It is based on interfacing ICs. So first look at the question. So here now read the question first, because sometimes in a tensed mode in the exam we get confused whether he is asking the options of correct or options of wrong. So first of all you have to be very careful regarding the question. What is the question he is asking about? Because in overlook every time we search for the correct answers. No, that is where you have to think, wait and think for a while. So look at the question. Which of the above statements is or are not correct? So this is where you should be very cautious. He is saying is not correct. Is it here? So this what you should understand very carefully. Not correct. Okay, sometimes we go which is correct, which are correct. So that's where you should be very cautious. So look at this question. For example, say first one. 8259A means the priority interrupt controller. Why is it actually used? Because a processor has got less interrupts to handle. Why interrupts? So the interrupts are from the external devices for the microprocessor, such that the microprocessor can provide some service to them. See, what is the main purpose of a microprocessor? To provide some service to the input output devices. So a processor cannot be used for itself. Therefore, whenever the interrupts are less for a microprocessor, few devices can only be connected. So if you want to increase the interrupt handling capability of a microprocessor, the IC called as 8259 is used, which is called as programmable interrupt controller, or in other words we can say priority interrupt controller. So here this 8259 can support 8 IO devices in a priority wise in different modes of operation, right? Similarly, if you can cascade certain 8259s for every pin of this 8259, another 8259 can also be connected. So one 8259 can support 8 devices, 8 into 8 8259s can support 64 devices. So that is the main purpose of 8259. So there are several modes of operation. So for example, if you observe here in this question, the first statement is 8259 is specifically designed for use with interrupt signals, that is the pin is INTR or INT of 8085 microprocessor. No, 8259 can be used along with 8085 and 8086 also. 8086 is a 16-bit processor, 8085 is an 8-bit microprocessor. So it is used for both 8085 and 8086, but it is given only as 8085 processor. So this is not correct. Similarly, it can solve 8 interrupt levels of interrupt priorities, because one 8259, for example, if you consider this as 8259, let us say this as 8259, so this can support 8 IO devices, 1, 2, 3, so on, etc. 8 means, for example, if I start from 0 to 7, it is 8 devices. So in a cascade mode, this pin can also be connected with another 8259. So I think it's visible, or I can simply write with a white color also, no problem. So this 8259s are possible. Okay, 1 minute. Fine. So here we can understand like one 8259 for each pin of 8259 master. These are all slaves, right? So how many it can handle? This can also handle 8 devices. Similarly, the second pin connected to another 8259 can also handle another 8. So 8 into 8 devices, it is simply 64 maximum IO devices can be handled whenever the 8 plus 1, 9 8259s are added together. It means maximum how many it can handle? 64 devices. So one can handle 8. So it is given as it can solve 8 levels of interrupt priorities in a variety of modes. Means one 8259 can handle 8 devices. That is correct. But look at the next one. With additional 8259A devices, the priority scheme can be expanded to only 32 levels he has given. But how many it can be done? 64 can be possible. Why 64? Because this is the master, and remaining all initial 8259 pins can be connected with another 8259. So this can handle 8. So every pin connected with other 8259 can also handle 8. So 8 into 8, maximum 64 is possible. Here simply given as only 32 levels are possible, which is not correct. So what are the options which are not correct? 1 and 3. So option A should be the correct answer. So we can say that option A is 1, and the option A is the correct answer for 85 question. Right, let us go for the next one. What is the next one? Consider the following statements regarding 8259 instruction set. So now look at the question again. You don't worry about the statements. First look at the question, because in the question, in the overlook, we don't study this not correct or correct. That is the main thing you should understand in the objective questions in the paper, right? Fine. Look at the question. So after execution of that again he's asking what? Not correct. So you must be very cautious here, right? So consider the following statements regarding 8085 instruction set. So what are the statements? Let us see now. Fine. So the first one is after execution of DAD instruction, if the result is larger than 16 bits, carry flag is set. So first let us see what is the meaning of this DAD instruction, right? Okay, fine. So if you observe here, what's the purpose of this DAD instruction? So in 8085 there are different types of instructions, like DAD instruction is one among them. So the main instruction is like DAD RP. This is the main instruction. DAD RP. So RP stands for register pair. DAD RP means this instruction is used to add the content of HL pair and any register pair. So any register pair means it can be BC register pair, it can be D register pair, it can also be HL register pair. So this instruction is something like 2 16-bit addition. Actually 8085 is only 8-bit microprocessor and can handle only 8-bit data, but by using this instruction we can add 2 16-bits data, but the result is stored in HL pair, not in the accumulator. So if you observe here carefully, whenever the content, for example I am considering an instruction called as DAD B. So DAD B indicates the content of BC are added to the contents of HL pair register. HL pair register pair. So when these two are added, the resultant value is also stored in the HL pair only. It means the resultant is also stored in the HL pair. So this is where the result is stored. So result is stored in this place. If the result you are adding these two lower bytes and adding these two higher bytes, so it is something like 2 16-bit data. One is 8-bit 8-bit. So 16-bit 16-bit. So finally if the result is more than 16-bit, then automatically that is reflected by the carry flag. Is it clear? So the first statement is what? Correct only. So after DAD, execution of DAD instruction, if the result is larger than 16 bits, it is affecting the carry. That is correct statement only. The next one is after execution of decrement instruction. What is decrement instruction? Decrement instruction DCR, or it can be another instruction like decrement register content, decrement memory content, or it can be decrement register pair content. So these are all different type of instructions. Let us say instead of writing this DCR, I am generalizing it as decrement register content, decrement memory content, and decrement register pair. In decrement instruction, we may decrement any of the register or memory or register pair by 1. But in decrement instruction, the carry flag is not affected. So only carry flag is not affected. Remaining all flags are affected. What are the 5 flags we have? Sign, 0, auxiliary carry, parity, and carry. These are the possible flags. So in the decrement instruction, so it is done simply like increment decrement latch can be possible. So here it may not involve the ALU sometimes. So therefore here the thing is that carry flag is not affected. There are several reasons why this carry flag is not affected, because here see in the decrement instruction we are not decrement. See, for example, if you decrement some data, something like let us say some data like FF or 00, if you just take 00, if we decrement -1, so how do you decrement this value? So therefore this -1 2's complement is added internally. Are you able to understand? So that is why the carry flag will not be affected in this particular instruction of decrement or increment. Is it clear? So therefore only carry flag is not affected. But what he says in the question, after execution of decrement instruction, sign flag and carry flags will not be modified. No, that is wrong, because sign flag can be modified. These all 4 can be modified except the carry flag. So this one is the wrong statement. So did you understand? So this is the wrong statement. This one is the wrong statement. And the third one, after execution of CMC, CMC stands for complement carry. Only carry flag is complemented. If it is 0, it becomes 1, 1 becomes 0. So that is carry will be changed. That is correct only. So first and third are correct, second one is wrong. So this is present in option B. So we can say 2 only. Clear? Right. So like this, depending on the instruction, you should know how it will happen. So this is how the flags will be involved in this particular. He has given the question regarding the flags of 8085. So 8085 has got 5 flags which will be affected based on the ALU operation. Right. Next question. If the memory chip size is 1024 by 1, so what is the size of memory chip given here? What's the size of memory chip given? So memory chip size, given chip size is equals to how much? 1024 by 1. What is the meaning of this? There are 1024 memory registers and every register can accommodate 1 bit, right? The next one is the number of memory, such type of memory chips needed to design 8 kilobytes of memory. So there is a simple notation for this: number of memory chips, I am denoting memory as m/m, okay, number of memory chips required to design 8 KB is equals to, very simple, it is simply memory to be designed by available capacity, So very simple. So what is the memory to be designed? That is equals to how much? What is the memory you want to design? 8 kilobytes of memory by what is the chip size which is available? 1024 by 1, means 1024 registers are there and every register contains 1 bit only. So now what is 1 KB actually? How we can expand this some more? For example, say 8 KB can be still written as 1024 by 8 by 1024 by 1. Are you able to understand? So 1 KB indicates 1024 registers and every register accommodating 8 bits. That is the meaning of byte. So 1 kilo means here 1024 and byte indicates that every register has got 8 bits. Therefore 8 into 1 KB size. Therefore you can simply cancel these 2 and this 8, that is 8 into 8, which will indicate 64. It means 64 such type of ICs are required to realize 8 kilobytes. How they would be connected? For example, say, so 1024 by 1 such type of ICs, there will be 8 such ICs in a row. In one row, 8 ICs will make it 1 kilobyte, because 1024 registers and 1 bit, 1 so on etc. Such type of 8 ICs will be there. As such, there will be some 8 rows. So one row indicates 1 KB. Such type of 8 rows would indicate 8 KB. I hope you have understood clearly, right? So one row is 1 KB and 8 such rows will indicate 8 KB. So 8 into 8 rows, that will simply realize the required memory design. So answer is 64, that is option C should be the answer. So option C is the answer, 8 into 8, 64. So I have given you a mathematical solution and also the design how actually it would be. It means the chip selects of all these chips in one row are parallelly connected. So all of them are selected at a time. So chip select of all the chips will be parallelly equally connected. So we will connect all the chips in one row, select all of them at a time. Like this 8 rows can be possible, right? So that is how we can design the memory. So 64 such type of memory chips are required. I hope you have understood this design, right? Let us go for the next question. Consider the following statements regarding 8051 microcontroller. Now first of all, in such questions what you must do, you must first read the question. Is he asking the statements which are correct or not correct, or else there is a chance of making mistakes. So we should be very cautious. So now he is directly asking the correct. So there is a little bit possibility, because remaining 2 questions earlier were negative sense, not correct. This one is correct. There is nothing to worry about this. So read the question. Consider the following statements regarding 8051 microcontroller. So the basic difference between processor and controller is what? Processor has got only ALU, C1 registers. Microcontroller contains the CPU structure, memory, and also IO, like timers and all IO interfacing circuits also, right? Now the first statement, the size of RAM in 8051 is 128 bytes. See, 8051 has got inbuilt memory, that is RAM and ROM. So inbuilt the RAM capacity in 8051 is exactly 128 bytes, and similarly ROM size is 4 kilobytes. Okay, so he is not asking about the ROM, he is simply talking about the RAM. So RAM is 128 bytes, exactly correct. Fine, next one, RAM locations. So this memory of 128 bytes is divided into 3 categories. So the 3 categories are something like the working registers and the bit or byte addressable registers, and the other one is the general purpose registers, or which can be used for stack 2. It means the one among the 128 bytes, so the 3 parts of memory can be in this manner. So like for example say 32 registers, means for example 00H to 1F. So these are 32 registers. These are called as register banks, in which the default bank, look, we can say that bank 0, bank 0, bank 1, bank 2 and bank 3. Are you able to understand? So by default bank 0 will indicate R0 to R7. So from bank 1 to all, these all indicate the stack memory. This indicates the default stack memory. Is it understood? So this indicates default stack memory, means from the address 0 to 7, that is first bank, that is bank 0. So bank 1 starts at which address? 08H. From 08 to 1F, these all remaining 24 registers are by default considered stack memory in 8051. These are called as working registers. So these are simply working registers. Working registers. Okay, working registers. Similarly, these are bit or byte addressable registers. This can be bit addressable or even byte addressable registers. Byte addressable registers. Fine. How many are there? 16 are there. Like for example, say what is the next address after 1F? 1F. It is 202 2F. So these 16 into 8, every bit is addressable, and similarly these are present. Clear? Last one is first stack. So remaining another bytes are meant for the stack. That's it. So what he says, so RAM locations 0 to 1F are assigned for register banks. That is correct only. This is correct only. Okay, I'm just writing like this. This is correct only. And last one, RAM locations 20 to 2F are meant also placed as byte. This one, byte addressable or bit. So he's saying available for, that is also correct. Fine. Is it clear? So working registers, these are also possible. Last one is time. So all are correct. So answer is D. The last one is 93. Consider the following statements regarding non-volatile Nvram. So there are several types of memory. One such is called as non-volatile memory. So this non-volatile RAM is a type of RAM which will not lose data. RAM is actually volatile memory. It is non-volatile, means even though the supply is off, data can be retained. How? There is a backup battery and some intelligent circuit or control circuit is there, which will immediately connect the battery to the RAM. So whenever the power is about to switch off, it will be connected to the battery supply, and hence automatically it is called as non-volatile. So this circuit is something like UPS, uninterrupted power supply. Clear? That is about the non-volatile, and you can program it, erase it a number of times, right? So look at this, when the power is turned off, the contents are lost. That is wrong. So he is asking which statements are correct. So this one is wrong, leave it. Nvram uses extremely power efficient SRAM cells built out of CMOS. That is correct only, extremely power efficient, because here whenever it is working with battery, whenever the power is not there, so you must use very efficient CMOS as a complemented metal oxide semiconductor cells, so that speed should also be more and consumes less power, right? Similarly, this is correct one. So similarly, it uses an intelligent control circuit. Why intelligent control circuitry? Because when the power supply is off, immediately the control circuit should connect the battery, same as UPS. So that is why these two are correct. Very simple logic. Observe here. When first statement is wrong, wherever the first statement is there, all should be wrong. Simple logic. So blindly also you can put the answer as C. Got it? Yeah. So that is the answer. Did you understand? So this is how the 5 questions can be easily solved. I hope you have solved well in microprocessor. Thank you so much for your patient listening. Thank you.
Hello everyone, welcome to the solution for EMT EC branch. Okay, so see the first question. The first question is, if V is a scalar, then the given equation in spherical coordinate system. But obvious, this is basically Poisson's equation, isn't it? So you can see that this is minus rho upon epsilon. This is basically minus rho upon epsilon. So basically for Poisson's equation, it is basically del square V is equal to minus of rho V upon epsilon. Now they have asked in the spherical coordinate system. So obviously in a spherical coordinate system there will be what? R theta and phi. So you can see that R theta phi, if you put this value you will get the answer. So what is the answer? It is basically option B. So option B is the correct Poisson's equation. Next question. Next question, it is saying that the intrinsic impedance of free space. So intrinsic impedance is nothing but your mu upon epsilon, which is equal to, for free space it is mu naught upon epsilon naught, which is equal to 120 pi or 377 ohms. So direct question. So 377 ohm is the correct answer. So option C. Fine. Now coming to the next question. Next question, which of the following is an angle at which there is no reflected wave when the incident wave is parallel or vertically polarized? Okay, so but obvious, there is no reflected wave. That means it is talking about the Brewster angle, as simple as that. They are talking about Brewster angle. So what will be the answer? Brewster angle, option D. Now coming to the next question. The condition for low loss transmission line. So low loss, but obvious, if R is very greater than, G is very greater than, then resistance very high, conductance very high, there will be more loss. But obvious, this is basically distortionless, right? And so there is only one thing, the resistance should be very less and the conductance of the transmission line should be very less. So but obvious, answer should be B. Coming to the next question, consider the following statements regarding impedance matching. The first statement, it is saying that when the line is terminated in an impedance other than its characteristic impedance, that means if it is suppose ZL and it is Z0, right? So other than that means ZL is not equal to Z0, what will happen? Obviously there will be reflection, and it is written reflection will occur and there will be standing waves. That means statement 1 is correct. Right, obviously may be very large if the considerable mismatch, that will depend. Now the single step device has the advantage that it will match any load, that is also correct. Fine. Now provided it is working in the narrow band frequency, right? So I think the more appropriate should be any complex load. It would have been very much good if यहाँ पे स्टेटमेंट होता है will match any complex load, but जब ये लोड बोल रहा है तो क्योंकि रेजिस्टिव लोड और कॉम्प्लेक्स लोड को भी हम लोग मैच कर सकते हैं प्रोवाइडेड इट इज इन द नैरो बैंड, लेकिन अब वेरिएबल लोड को हम नहीं कर सकते. जैसे आप लोड वैरी कराओगे तो स्टब की पोजीशन चेंज होती रहेगी. तो अगर सिर्फ एनी लोड बोला गया तो हम ये मान के चलेंगे कि लोड को फिक्स कर दिया गया है एट और उसी को हम लोग मैच कर रहे हैं. तो इट कैन मैच एनी लोड प्रोवाइडेड, क्योंकि सब में इसने थोड़ा सा डिटेलिंग किया है, क्योंकि आप इसमें देखो द डबल स्टब हैज द डिसएडवांटेज दैट द लाइन लेंथ नीड टू बी एडजस्टेबल, यानी कि आपको लाइन अकॉर्डिंग टू द लोड, एडजस्टेबल कहने का मतलब ये है कि लोड चेंज करोगे तो इस तरीके से. तो इसने क्लियर किया है. इसमें थोड़ा सा और एक दो वर्ड लगाता एज फॉर एग्जांपल की मैच एनी लोड इन नैरो बैंड फ्रीक्वेंसी तो ज्यादा एप्रोप्रिएट हो जाता, लेकिन फिर भी हम लोग ये मान के चले कि ये जनरल कंसीडर किया गया है तो सेकंड स्टेटमेंट भी सही हो जाएगा बिकॉज इट इज द एडवांटेज. एडवांटेज किसके रेस्पेक्ट में? क्वार्टर वेव के रेस्पेक्ट में. ठीक है, वो क्लियरली मेंशन नहीं है, लेकिन अगर आप देखोगे क्वार्टर वेव को ही हम लोग उसको हटाने के लिए हम लोग बेसिकली जो डिस्क्रिपेंसी को हटाने के लिए हम लोग सिंगल स्टेप यूज करते हैं. ठीक है, द डबल स्टेप ये भी सही है. तो आंसर क्या होना चाहिए? 1, 2 and 3. सो आंसर 101 का डी. ओके, कमिंग टू द नेक्स्ट क्वेश्चन, द वेव इंपीडेंस है ना. तो ये तो बहुत सिंपल सा क्वेश्चन है. यू कैन सी द टी वेव. तो टी वेव के लिए ईटा टी क्या होता है? इट इज इक्वल टू ईटा टी एम अपॉन रूट अंडर 1 माइनस एफ सी अपॉन एफ का होल स्क्वायर, इजंट इट? तो आप देखो ऑब्वियसली 2 तो हो ही नहीं सकता, कहीं पे भी 2 तो आता ही नहीं है. रही बात इस दोनों में कहीं भी पॉजिटिव नहीं आता, देयर इज ऑलवेज नेगेटिव साइन. तो ऑब्वियसली इससे आप डायरेक्ट देख सकते हो आंसर इज सी. करेक्ट. नाउ coming to the next question, which of the following is the ratio of power lost per unit length to the power? Actually ये क्या है? Basically this is called as alpha g, है ना. इसको जो basically it is called as attenuation which is equal to p loss upon 2 times of power transmission. So ये basically waveguide में हम लोग low loss waveguide के लिए use करते हैं इस चीज को, right? So therefore as answer should be attenuation factor. Fine. Now coming to the next question, a section of x band. तो इसके लिए हम लोग देख लेते हैं क्या है. ए दे रखा है, बी दे रखा है, सारा चीज दे रखा है. आपसे पूछा गया कट ऑफ फ्रीक्वेंसी क्या होगा? एफ सी फॉर टीई 10 इट इज इक्वल टू सी अपॉन 2a और नॉट सी we can say that it is V upon 2a, where V is equal to C upon root of epsilon r. क्योंकि if you look at this particular case, इस केस में देखिए epsilon r दे रखा है, म्यू r की वैल्यू 1 दे रखा है, तो आपको इसकी वैल्यू सब्स्टिट्यूट करनी होगी. तो कट ऑफ फ्रीक्वेंसी कितना हो जाएगा? C अपॉन 2 रूट ऑफ epsilon r इंटू ए की वैल्यू आपको सब दे रखा है. जब आप इसको सब्स्टिट्यूट करोगे, सो यू विल गेट द वैल्यू एज 4.53 गीगाहर्ट्ज. ठीक है. नाउ द क्वेश्चन अराइजेस. अब स्टूडेंट बोलेगा सर ये सिग्मा क्यों दे रखा है ना? द मोस्ट इंपॉर्टेंट थिंग कि व्हाई सिग्मा. एक्चुअली क्वेश्चन जो है ये भी कहीं मतलब कि इट हैज नॉट क्लियरली मेंशन्ड. एक्चुअली सिग्मा से हम लोग सरफेस रेजिस्टेंस या फिर अल्फा इन डीबी पर मीटर निकालने के काम में आता है, इसीलिए सिग्मा डी दे रखा है. उसने मे बी कहीं से उठाया है क्वेश्चन, लेकिन पूरी तरीके से जो एक्चुअल क्वेश्चन था उसका डेटा तो ले लिया, लेकिन क्वेश्चन को थोड़ा सा उसने उस हिसाब से सेट नहीं किया. तो अल्फा डी देने का मतलब कि अगर इसने सरफेस रेजिस्टेंस या फिर अल्फा इन डीबी पर मीटर पूछा होता तो हम सिग्मा डी का यूज करते हैं. कट ऑफ फ्रीक्वेंसी में डायरेक्ट फॉर्मूला का यूज होता है. राइट. नाउ कमिंग टू द नेक्स्ट क्वेश्चन. द एंटेना और द एंटेना array designed to yield directive gain appreciably greater than that obtainable from uniform distribution has become known as. obviously तो आपको क्या चाहिए? एंटेना array designed to directive gain, इसको हम लोग क्या बोलेंगे? इट इज कॉल्ड एज सुपर गेन एरे. सुपर गेन एरे में वी ऑलवेज डिजायर हैव टू हैव ग्रेटर गेन. करेक्ट. तो डायरेक्ट है. अच्छा, ये जो क्वेश्चन है 108, इसको देखिए, इसने बहुत इंटेलिजेंटली क्वेश्चन को सेट कर दिया है. एक्चुअली इसमें कह रहा है इन द रिलेशन बिटवीन द फील्ड एंड द पोटेंशियल आर इज लेस देन ए, देन द पोटेंशियल एट अ पॉइंट आर इनसाइड अ यूनिफॉर्मली चार्ज स्फीयर. यूनिफॉर्मली चार्ज स्फीयर का मतलब ये हो गया कि मैं आपको रफली, क्योंकि आप इसका डिटेल सोल्यूशन आपको वेबसाइट में मिल जाएगा. कहने का मतलब ये है कि इसका रेडियस a है और ये r रेडियस पे है ना. हम मान लेते हैं कि रो इसका सरफेस चार्ज डेंसिटी है. फाइन, ये रो सरफेस चार्ज डेंसिटी है. आपसे पूछा जा रहा है कि व्हाट इज द पोटेंशियल एट अ पॉइंट r इनसाइड. यहां पे क्या होगा? ठीक. तो इसमें दो चीजें करनी होगी आपको. पहला चीज जो करना पड़ेगा कि आपको गॉस लॉ लगाना पड़ेगा. d डॉट ds इज इक्वल टू रो वी dv, है ना. गॉस लॉ पे क्वेश्चन है. ठीक है. अब यहां पे दो केस लेना पड़ेगा. केस 1, व्हेन रो is less than, or you can say that r is less than a. इस केस में आपको इलेक्ट्रिक फील्ड निकालनी होगी. तो मैं डायरेक्ट लिख देता हूं, इसको पूरा मैं सॉल्व नहीं करूंगा क्योंकि आप इसको वेबसाइट पे जाकर के इसका कंप्लीट सॉल्यूशन देख सकते हो कि किस तरीके से हमने निकाला है. इलेक्ट्रिक फील्ड की वैल्यू आ जाएगी रो r अपॉन 3 एप्सिलॉन नॉट. ठीक है. और केस 2 आपको निकालना पड़ेगा जब r की वैल्यू ग्रेटर देन a है. तो इसमें जब इलेक्ट्रिक फील्ड निकालोगे तो ये आ जाएगा रो a क्यूब अपॉन 3 एप्सिलॉन नॉट r स्क्वायर. ठीक है. एक बार जब इलेक्ट्रिक फील्ड आ गया, आपसे पूछा जा रहा है पोटेंशियल. पोटेंशियल कैसे लिखोगे? E डॉट dl. इलेक्ट्रिक फील्ड चाहिए होगा फ्रॉम इंफिनिटी टू एट अ डिस्टेंस r. यानी कि हमेशा याद रखिए जब भी स्फीयर लेते हैं फ्रेम ऑफ रेफरेंस हमेशा इंफिनिटी पे लिया जाता है, क्योंकि पोटेंशियल एट इंफिनिटी इक्वल टू 0 और फिर ऑब्जर्वर ऐसे आएगा. करेक्ट. ये होता है कॉन्सेप्ट. तो इंफिनिटी से लेके r. तो आप इसको कैसे लिखोगे? आपको E पता है. dl इस केस में क्या हो जाएगा? dl जो होगा वेक्टर, इट विल बिकम dr, है ना, ar. या फिर मैं इसको डायरेक्ट ऐसे लिख लेता हूं, dl जो होगा dr के बराबर होगा. दोनों केस में, है ना, इस दोनों के केस में dl की वैल्यू dr के बराबर हो जाएगी. करेक्ट. इस केस के लिए भी और इस केस के लिए भी dl की वैल्यू dr. बस आपको सब्स्टिट्यूट करना है E डॉट dl. ठीक. अब इसको इंटीग्रेशन करोगे कहां से कहां तक? इंफिनिटी से लेकर के a, ठीक, प्लस a से लेकर के r तक E डॉट dl. करेक्ट. जब आप इसमें प्रॉपर ये वैल्यू पुट करके इंटीग्रेट करके फाइनल आंसर निकालोगे तो आपका जो आंसर आता है वो आ जाएगा v इज इक्वल टू रो अपॉन 6 एप्सिलॉन नॉट 3 टाइम्स a स्क्वायर माइनस r स्क्वायर. ये आ जाएगा आंसर. तो सोल्यूशन मैंने आपको रफली बता दिया है. आप इसको डिटेल आप वेबसाइट पे देख सकते हो. तो कौन सा ऑप्शन सही हो गया? सो दिस इज इक्वल टू सिग्मा अपॉन सॉरी रो अपॉन 6 3 a स्क्वायर माइनस r स्क्वायर. आंसर क्या आ जाएगा? आंसर इज b. करेक्ट. ओके. नाउ coming to the next question. Okay, so these were the basically questions that were asked from the EMT. So thank you.
Now they are going to discuss the network problems. So first question is, which one of the following represents a single element such as a voltage source or a resistor? The what options are branch, node, loop, circuit. So very simple, this is the question is, answer is directly you can say there is a branch. So node is more than two branches or more than two branches are connected at a junction, that is called the node. Here loop means there must be a more than two elements, and circuit means a loop hona chahiye. Okay, so single means there is a branch only. Next question is, what is the value of maximum power transferred to the load resistor RL in the given circuit? Not only here RL, you have to find out the maximum power absorbed by the load. What is the formula for P maximum? P maximum is equal to VTH square by 4RL or 4RTH. So find out the VTH means open circuit voltage. RTH is, how to find RTH? You open circuit the current sources and short circuit the voltage sources. Now I am open circuiting the, first find out the RTH. RTH is here 2 ohms, 6 ohms, 12 ohms and 3 ohms and 2 ohms. So looking from here as a load, this is RTH. 6, 12 in parallel and series with 3 ohms and here series with 2 ohms. 6 parallel with 12 plus 3 plus 2 is equal to RTH. So 5 plus 4, RTH value is 9 ohms. One is completed. The second step is you have to find out the open circuit voltage. Now open circuit here now. Here open circuit कर सकते हैं here open circuit. Here the VTH. So what is the current flowing to the 2 ohm resistance is 0 amperes. So you can use either nodal analysis or a mesh analysis or source transformation. So तीन में एक use कर सकते. Otherwise another also possible. Very simple way is. Very simple way is A भी कर सकते. You would first find out the voltage across here VTH. You would find out here. Then RTH also find out here directly. So what is VTH here? The VTH voltage across here. पहले तो VTH dash बोलता हूँ. VTH dash. So first find out here VTH dash is 12 into here 12 by 12 plus 6 18. So 3 4s are 3 6s are 6 1s are 6 2s are. Here is a between these two terminals the VTH dash is 8 volts. So now you can find out the RTH between these two terminals 12 6 in parallel, that is a 4 ohms. Now it can be written as, you can draw the now the circuit is here VTH dash is how much? You get a now 8 volts in series with 4 ohms and here is a 3 ohms. Now here is a 2 amperes. Our intention is find out here 2 ohms no current is flowing, here is the VTH. Here 2 amperes. Now write a loop equation directly. So here the plus minus, here 6 volts drop is, here is 8 volts drop. 8 8 16, 16 plus 6 is 22, VTH is equal to 22. This is one way. Otherwise you would use source transformation or use mesh analysis. So P maximum is equal to VTH square by is 22 into 22 by 4 into RL. You get a nearly equal to 13.44 watts. So the option is here C is the correct answer for this question. Okay, very direct question this is. So next question is, in the given figure below, the value of voltage drop across the resistor R1 is. It's a very simple question, just use the voltage division rule. Here suppose you are ground, the voltage is 40 volts, these two are in series. the volt across R1 is here VR1 is equal directly, you can use voltage division rule. 40 into these two are in series, so 100 upon 100 plus 300, that is a 400. So 0 0 get cancelled, 4 4 get cancelled, so the value is 10 volts. So what option is here now? 10 volts is a B is the option for this question. Next question. What is the value of the source current Is of given network figure? Is is the current coming from the voltage source. So here is suppose if you are using mesh analysis, it will take a more and more time. You are using node analysis, so how many number of nodes are there now? Here is a here V1 and V2. V1 is equal directly 12 volts लिख सकते, and V1 and V2 you write a two equations, solve equations and write a KCL equation, get a answer, but it will take a more and more time. Only one source is there, remaining are resistances. Use reduction technique only. Here to use star to delta technique, here just use star to delta, either these 12 6 18 in a delta, 4 6 9 in delta, anyone you have to convert a star, you have to convert star. Here what is this value is 4 into 6 by opposite upon 4 plus 6 plus 9, and this value of resistance 6 into 9 by 6 plus 9 plus 4, this value is 4 into 9 by 4 plus 6 plus 9. After here replace with a star, these two are in series and these two are in series. Next is parallel and series. So to find out R equivalent total. Okay. So then Is is equal to 12 by R equivalent. You get a nearly, you get a answer is 1.2 milliamperes. So this is some lengthy question. This is okay. So the which one the following properties of circuits of a graph are correct? Is given statements here now. What are the statements are correct in this question? What a statement is here now? The minimum number of branches possible in a circuit will be equal to the number of nodes or vertices. You take any graph, suppose branches possible. Suppose you take a simple example. Your one example is one node, there are two nodes or three. Here is a minimum number of branches are possible in a circuit will be equal to the number of nodes or vertices. How many here nodes are? 1, 2, 3. So total equal to how much here now? Number of minimum number is 3 and also number of nodes also 3. Both are equal. There are exactly two paths between any pair of vertices in a circuit. Is statement is correct or not? No, it is not a correct. Why? Because these are two pair of nodes. Maybe only one path हो सकता है, maybe two paths हो सकता है, maybe three paths. Infinite number of paths होने की chances है. So there are only exactly two paths दिए. So इसलिए so the statement 2 is not a correct. It's not a correct. There are at least two branches in a circuit. There are at least two branches in a circuit. Circuit means there must be a closed path. So at least two branches होना चाहिए. Yes or no? If forming a loop means here is a one branch is another branch is required to form a circuit. Circuit means there must be required a closed loop. So this also is correct. 3 also is correct. So 1 is correct and 3 is correct. So the option is here the B. So remaining questions, so Kiran sir will discuss.
Good evening, dear students. Come to the next question. Now correspond this question. First you have to read the given statements very carefully. In this example, if you observe the question, what the first one is asking the open circuit reverse voltage gain. Reverse voltage gain. This voltage gain and current gains are possible correspond H parameters. That means indirectly the question is asking H parameters. Chaliye. First, what is the requirement of the open circuit reverse voltage gain? Now for that one, if you write the standard H parameter equation, but the requirement is a voltage gain. Voltage gain means we need the ratio of the V1 and V2, V1, V2. That means you have to find out the H12. In this example, to convert the H12, this V1 by V2, V1 by V2. To get this one, what is the condition for this one? I1 equals 0. I1 equals 0. Now this is a reverse voltage gain, reverse voltage gain. Now come to the given network. In this one, what is the condition? I1 0. I1 0 means input is the open circuit. Input is the open circuit. Corresponding terminals voltage is the V2. Whatever the current is the I2. What is the requirement of the voltage ratio? Even though it is open circuited here, voltage exists. Voltage exists across these terminals V1. Can we say this here? Once it is open circuited in the 12 ohm resistor, no current is circulating. No current is circulating. Then here this V2 will be distributed in the first element and the second element. Voltage across 6 ohm resistor and V1 both are the equal. Simply can use the application of the voltage division technique. If you apply the voltage division technique, V1 equal to, for these two elements, what the total voltage is V2. Total voltage is V2. Similar resistor. देखिए जी similar resistor कितना इधर 6 by total resistance 6 plus 3. That means if you simplify this one, this V1 by V2, V1 by V2 equal to, what the answer for this is 2 by 3. Now first one is completed. V1 by V2 equal 2 by 3. चलिए अब options देखेंगे. Check it out in the options. Anyone is supporting here? Yes. C option is supporting. C option is supporting. That's why here without finding the second parameter, only by using the elimination process, we can come to the C answer. Okay. Come to the next one. Again, this is also 2-port network question. Either be, again you have to read the given statements very carefully. Open circuit transfer admittance. Now this open circuit transfer admittance is possible correspond to ABCD parameters. Now correspond these ABCD parameters. If you write the standard equation, what about this I1 equation? Now this standard equation corresponds to these ABCD parameters. But the requirement is one requirement of open circuit transfer admittance. That means indirectly the question is asking to find the C value. First requirement is the C value. I1 by V2. What is the condition for this? I2 equal 0. I2 equal to 0. Output is the open circuit. इधर देखिए. Now what is our requirement is we need the relation between the I1 and V2, ratio the I1 and V2. देखिए in this example it is a open circuit at this portion. This I1 current distributed in the branch 1 and this branch 2. Can you find out this branch 2 current? Let us name this current as a I dash. Can you apply current division technique for this one? I dash equal total current to opposite resistor. Now for this entire branch, what is the opposite resistor is 42 by total resistance. By simplifying this one, I dash is obtained. Now let us name this for the equation 1. मगर आपको क्या चाहिए? We need the V2 I1 relation. देखिए इधर voltage across this one both are the same. Then in this example we can conclude that the V2 is equal to 10.5 I dash. Now let us name as the equation 2. Now can you substitute this equation 1 and equation 2? Now if you substitute the equation 1 and equation 2, check it out by simplifying this one. Directly I am writing here Now here answer will be 1 by 6. Substitute this equation 1 in equation 2. Simplify करो. Simplify करने से we can find out the ratio 1 by 6. अब देखिए options we can verify. Now which options are eliminated here? Now which are the incorrect options? A is incorrect and D is also incorrect. Come to this B and C options. In the B and C options, again what you have to find out, what is the one more requirement is the short circuit current ratio, negative short circuit current ratio. That means indirectly is asking to find out the D value. He is asking to find out D value. Chaliye, let us find out D value. Now find out the D, what is the ratio is the I1 by I2. But the condition for this one, V2 equal to 0. V2 equal to 0. Now short circuit. Output terminals are short circuited. Output terminals are short circuited. In this example here the short circuit and 10.5 both are in the parallel. Now what is the equivalent resistance equal 0? That means this branch can be neglected. Now we can remove this branch. If this branch is removed, now what is the current here? I2. क्या चाहिए आपको? Now what is the requirement? The minus I1 by I2. What requirement? Minus I1 by I2. Now for this one simply can you apply current division technique? If you apply current division technique, total current for these two branches, total current is I1. To get the branch 2 current, total current to opposite resistor. But the opposite resistance for this one is 42 by total resistance. In this example, total current is acting forward direction, but what about I2 in the backward direction? Then what is the sign for this one is a minus. By simplifying this one, can you find a ratio this one also? Check karo ji. Here the correct answer. The correct answer for this one is B, 3 by 2. 3 by 2 and 1 by 6. Come to next one. Now in this example here, whenever the switch was present at position 1, in the data itself given, inductor initial value, capacitor initial values are given. At t equals 0 seconds, the switch is the transferred to position 2. We can solve this problem with different approaches. One approach for this one is to apply the Laplace. With help of the Laplace, we can find out a current response. That is one way of solving problem. Now this other easy approach is simply apply the classical method. If you observe the options here, in all the options 2 exponential terms are present. That means given system is come under the overdamping system. Now for this overdamping system, what is the general equation is now for this overdamping system, the general equation for the response. Now can you find out respect to alpha value, beta value? Now what is the alpha formula is minus R by 2L. What is the beta equal to? R by 2L whole square minus 1 by LC. In the question itself, resistance value is given, inductance value पता है आपको, capacitance value पता है. By substituting respective values, can you find out the alpha value, beta value? Check karo ji. Then you can substitute the alpha minus beta and alpha plus beta. Checked out. Then what will be answer? Any response? Check karo. The B is the correct option. Okay. Now this other approach for this one is the Laplace. Come to the next one. Again in this example also, here the source magnitude depends on the time. When the source magnitude depends on the time, we can find out response by using Laplace. Laplace is easier approach. For that one, simply can you apply nodal analysis for this one? First transform this one to S domain. Transform this one to S domain. Now what is the Laplace of this one is in the question it was given as milliamperes. Can you add the node equation here? Can you add the node equation? in this example here by KCL, now what are the incoming current? Now remaining currents are the outgoing currents. In the question itself, resistance value is given, capacitance value is given. By substituting respect to resistance value and capacitance value, can you find out the voltage response? Can you find out the voltage response? Now find out the voltage response. After finding voltage response, apply the inverse Laplace. After finding voltage response, apply the inverse Laplace. Okay. Checked out. Answer for this one is a C. C is the correct option. Come to the next one. Again, this is also very easy question. In the question, which one is given here? RC circuit with source. RC circuit with source. Now correspond to RC circuit with source. What is the nature of current response? RC circuit with source. What is the nature of current response? Is exponential decay. Either confusion mat hona hai. Voltage response is exponential rise. But current response is exponential decay. In the question he is asking regarding the current at one particular instant. At what instant here? 150 milliseconds. Now what is the current equation? V by R exponential of here by देखिए, by applying elimination process directly you can conclude the answer. Now if you observe the given information here, देखिए voltage value कितना दिया है? Voltage of this one is a 100. But resistance of this one is a 10 kilo ohm. Exponential of minus T by RC. That means if you observe this first term here, constant value, how much we got here? 10. Now which one supporting here? This C is the correct option. Without verifying all these things, either these are 100, 50, 20, but these are only 10. C is the correct option. Okay. Come to next one. Now in this example, what is asking the voltage response? Voltage response correspond to capacitor. In the data itself, initial value is given. Initial value is given. To conclude this one, voltage response easy way. To conclude this voltage response easy way here. Simply can use the general equation. V of 0 plus minus T by RC. V of infinite. What is the requirement of the voltage response? For that one we can use the general equation. Either देखिए, in the question itself given, now correspond given information. Now what is the initial voltage? How much here? 25 volts. Question में दे दिया आपको. Initial voltage कितना है इधर? 25 volts. Initial voltage है 25 volts. और क्या चाहिए to conclude the answer? V of infinite. That means can you develop the equivalent circuit at T equal to infinite? At T equal to infinite, what is the capacitor will be open circuited. Under steady state condition for DC source, the capacitor behaves as an open circuit. Capacitor will be open circuited. Once the capacitor is open circuited, this entire voltage come across the open circuit. Then what is the answer for this one is the V of infinite. V of infinite equal 40 volts. What is V of infinite is 40 volts. Again, can you apply the elimination process? Check karo ji, which option is supporting here? Checked out. A is the correct option. A is the correct option. Now the last one directly can conclude. Now what is the first statement? First statement is the definition for the voltage. That is the correct statement. But the second statement is the definition for the power. Definition for the power. But both are the correct and both are the independent statements. Independent statements. Then what is the appropriate answer for this one is the B. Appropriate answer for this is B.
Hello everyone, good evening. Let's take up control system questions as part of this ES prelims exam. There are 3 more questions, 54, 55, 56 also. I'll add them. Let me start with this. A unity feedback system has the open loop transfer function k 2s plus 1 upon s 4s plus 1 s plus 1 square. What is the value of k for the steady state error of the system to be less than 0.1 when the input is this? So, it's a type 1 system. Steady state error of a type 1 system for ramp input, it is 1 by kV. Steady state error of a type 1 system for ramp input, it is 1 by kV. For step input, it is 0. For this part, it is 0. For this part, it is 1 by kV, but amplitude 5 by kV. kV of this system is k. So, 5 by k. This has to be less than 0.1. That means the value of k has to be greater than 50 is the answer to the question. Next question. Question is, what is the value of k for the steady state error to be 10%? What input it is not mentioned, but it is a type 1 system, steady state error of a type 1 system for ramp input, it is finite. So, steady state error of a type 1 system for ramp input 1 by kV 10%, that is 0.1. What is kV of this system? kV is 5k upon 6 multiplied by 7 multiplied by 8. So, substituting that here, we get the value of k to be 672. In this, in an underdamped second order system, the time required for the waveform to go from 0.1 to 0.9 of the final value will be. Actually, in an underdamped second order system, we don't use this range. We don't call it to be 0.1 to 0.9. We call it to be 0 to 100% of the final value is what we call in case of second order underdamped system. This definition is suitable for overdamped system or it is suitable for first order system. But anyway, no other option matches other than taking it to be the rise time. But for underdamped system, rise time is defined to be 0 to 100% of the final value, not 10 to 90. I mean, unfortunately, that range is given, but among the possible options, the option that I go by is rise time. Open loop transfer function of a system is given. By what factor the amplifier gain k has to be multiplied so that the damping ratio zeta changes from 0.25 to 0.75. We know that zeta is inversely proportional to root k. So, from this we can say that k2 is k1 times zeta 1 by zeta 2 square, where zeta 1 is 0.25, zeta 2 is 0.75, this becomes 0.111. Answer to the question is option A. Consider the following statements regarding feedback compensation of control system. It's like consider a feedback control system is what it is. A faster response can be achieved by use of parallel compensation. See, parallel compensation in the sense, like a PD controller, if I say, we can use P in parallel with D, P plus D, we can imagine somewhat like that, parallel compensation. Of course, PD controller will enhance the speed of response. Of course, we can consider it to be a true statement. The environmental, it is true. The environmental conditions in which the feedback control system is used will affect the stability of the system. Yes, it does, because sensitivity and stability are inversely related, and sensitivity is the change in the output due to the change in the system parameters or the input, and the parameter changes due to the environment effects. Yes, the stability does get affected due to the environment in which the system is being used is a true statement. Third, the degree of accuracy and the stability of control system can be improved by the use of cascade compensation. Now, which controller or which compensator is to be placed in series? Say in series, the question is the degree of accuracy and the stability of the system. Say we usually use like say a PD controller or a PID controller in series with a plant, cascade compensation, which can definitely improve the speed and accuracy of the system. So, we can take it to be a true statement as well. So, answer to the question is 1, 2 and 3. Consider the speed, a speed control system given in figure. Question is to find the value of k such that, what is that? What is the value of k for which the steady state error to unit ramp input is less than 0.01. Obtaining the closed loop transfer function of the system. Question number 126. The open loop transfer function of the system, it becomes 10k upon s plus 1. This is open loop transfer function, which is a type 1 system. First we need to solve this inner feedback loop, multiply with this controller. This will be the open loop transfer function, type 1 system. Steady state error of a type 1 system for ramp input is 1 by kV, which is 1 by 10k. This has to be less than 0.01. So answer k has to be greater than 10, not even 10. So among the options given, the correct option is 14, because it has to be greater than 10. A subsystem that generates the input to the plant or process is known as, it is usually the controller. If it is uncompensated system, then we call it to be compensator. The word plant or process, as far as the time domain is concerned, the device that provides input to a controller, to a plant, is usually a controller. Consider the following statements regarding compensator. Lead compensator reduces the noise signal level relative to the control signal is false statement. What we have to find is which are correct statements. Okay, so lead compensator is functionally high pass. It enhances the system bandwidth, thereby noise will be more. Second statement, introduction of cascade lead compensator increases the gain crossover frequency. Yeah, that's what I said. Lead compensator increases gain crossover frequency, thereby it increases bandwidth of the system. This is true, this is true. 2 and 3. Answer C. Which of the following is used when the cascade compensator does not employ purely integration? Only pure integration means like K by S. When pure integrator is not supposed to be used. Why? Because pole at origin, that causes the stability to reduce. Right? Pure integrator will definitely reduce the speed and stability of the system. But we need the job of the integrator. So analogous to integrator will be lag compensator. Lag and integral controller, they are analogous. When a pure integral controller is not to be used, but a similar kind of impact has to be brought into the system, then one can go for lag compensator. Which one of the following techniques can be used to analyze and design the effect of a loop gain, that is open loop gain, upon the transient response and stability of the system? That's a direct answer, root locus. Root locus is a method in which we consider open loop gain to be the parameter and we study the system characteristics based on that. There's a definition of root locus. Consider the following statements regarding time response specifications. Delay time is the time required for the response to reach from 10 to 90% or 5 to 95% or 0 to 100%. All this suits for rise time, not for delay time. So statement 1 is false. What we have to find is which is not correct. Second, peak time is the time required to reach to the first peak overshoot. That's true. Second, delay time definition is 0 to 50%. Settling time is the time required for the response to reach and stay within a specified tolerance band, maybe 2%, 3%, 4%, 5% of the final value, not of the initial value. This is the wrong word in the statement. So this is false. We have to find the false statements 1 and 3. Answer to the question is B. Next. Transfer function is the function that relates the current or voltage at one port with that of the current or voltage with the other port. The ports are usually one is input port, the other output port. Transfer function is the relation between the variable of the output port with that of the variable of the input port. That variable may be current or voltage. Yeah, that's true, of course. Transfer function has if the transfer function has one or more poles in the right side of a plane, that is called as non-minimum phase system. Minimum phase system is the one which has got all the poles and zeros in the left side. Non-minimum is the one which has either zero or pole in the right side. Yeah, this is also true statement, but they are nowhere related. This is no way explanation to that one. Okay, so we can take the option to be option B. Both the statements are correct, but second one is not the explanation for the first one. Right, here I would like to add those 3 questions that are there. Question number 54, 55 and 56. Question number 54, it is mentioned that if there is an nth order system and with one input and one output, then what will be the dimension of the output matrix, C matrix. Say in C matrix, number of rows will be number of outputs number of columns will be number of order of the system. So 1 cross n. Question number 55. While obtaining this state model of RLC network, then we consider the state variables to be. So in case of RLC, a second order where 2 state variables are required, we always say that current through inductor and voltage across capacitor happens to be the state variables. Question number 54, answer C. Question number 55, that is option D. Question number 56, a parallel RLC network is given. Question is to identify the state equation of that. All 4 options have got the same first row 0 1 0 1 0 1, so let's not mess up them. The second option, which can easily be obtained by applying KCL in that RLC network, as I is equal to IR plus IL plus IC. This I is given to be I naught sine omega t. This IR is V by R, VC by R, IL plus C dVC by dt. By writing equation for VC dot, we get the answer as option D, that way. So these are around like 17 to 18 questions are there of control system in electronics and communication paper, which is an extraordinary weightage. So hope you might, all are easy questions. Those 17-18 questions hardly requires maybe 10 to 15 minutes of time. You all might have done. So I'm really happy that we got this many questions, and the two of moderate to easy level. So wish you all the best for the future endeavor. Thank you.
Next, let us see the solutions of the basic electrical engineering. Come to the first question. In the first question, what is the statement given as a, which of the following statement is a correct? First, you have to understand this point carefully, because some of the questions he is asking not correct. But here, what is the requirement is a correct. Can you read the statements? What the first statement given as a stator voltage changed, the torque will not change. But in case of the induction motor, torque is directly proportional to approximately V square. Wherever the supply voltage changes, torque value also changes. That means, sir, the first statement is incorrect. First statement is incorrect. Come to second statement. The motor has a no starting torque. It is also incorrect, because no starting torque statement applicable for the synchronous motor. But here, what is the given motor is which one here? Induction motor. Given motor is the induction motor. That means second statement also correct. Second statement also incorrect. But the third statement given as a high slip. Slip torque is inversely proportional to which one? Square of the slip. But in case of the high slip, torque is we can write this as inversely proportional to only slip. But what is the statement given as square? That means it is also incorrect. The first 3 statements are incorrect. But the last statement given as a low slip, torque is directly proportional. Yes, this statement is correct. In the low slip region, torque is directly proportional to slip. That's why what the shape of the graph is linear. Shape of the graph is linear. But the correct answer is D is the correct option. Come to next one. What is the requirement is to eliminate the fifth harmonic induced voltage. Now we have to find out the corresponding angle. Now for this one, what is the general formula is to eliminate the nth harmonic component. To eliminate the nth harmonic component, what general formula is 180 by n. The meaning of n is the nth harmonic. In this example, what is our requirement is you have to eliminate the fifth harmonic. Fifth harmonic, that means 180 by 5. 180 by 5. If you simplify this one, then what is the angle for this one is 36. What is the angle for this is 36 degrees. Come to the next one. Now if you read the statements carefully, Now again, what is asking is what is the main merit of the nuclear power plant? If you observe the given statements carefully, in case of the thermal power station, very large spaces are required for storage of the coal. But in case of nuclear power station, the coal requirement is very less. That's why here, what the correct answer for this one is the as compared to thermal power plant, the space requirement is less. Okay.
Hello everybody. Just I'm going to continue this for few questions. Like this question already done, correct. Now come to the next. Which one of the following is not a part of the nuclear reactor? Nuclear reactor का construction का already slide से बताया था. So in that case, yes, moderator is there, economizer is also there, reflector, biological shield, correct. So economizer is basically in that thermal power plant to increase the efficiency of that thermal power plant, correct. The heating efficiency, what you can say, right. Economizer क्या होता है? Not, यानी कि ये आंसर हो जाएगा हमारा. मॉडरेटर भी होता है, शील्डिंग भी होती है, रिफ्लेक्टर भी होता है, बट इकोनोमाइजर नहीं होता है, ठीक है. तो इसका सी हो जाएगा. Then come to the efficiency of a nuclear power plant. So the efficiency जो होता है इसका just 35% करेक्ट के आसपास होता है, तो 35% ही हम टिक करेंगे. Now come to the voltage induced in a coil by changing flux will be such a polarity that if a current could flow, yes. So see Lenz law, what is Lenz law? उस voltage induce होकर के जो current आएगा, correct, that current, the flux of that current will oppose the cause, correct, यानी कि वो जो previous flux था, तो ये क्या था? Lenz law. तो आंसर क्या हो जाएगा? Lenz law. सिंपल ना, बेसिक. So I always repeat in class, basic is important in basic electrical engineering. Now come to the last question, I think, from the subject. The measure of a coil's ability to produce flux is called, यानी कि see the flux जो प्रोड्यूस हो रहा है, what is the effect? That is flux. So उसका cause क्या होता है? तो that is magnetomotive force, MMF जिसको हम बोलते हैं. Just like in electric circuit and magnetic circuit, I have done comparison in class also. In electrical circuit, EMF is the cause, current is the effect. In magnetic circuit, correct, MMF is the cause and the flux is the effect, correct. The flow in the magnetic circuit is flux and the cause is MMF, right. So I think, yes, this is the last question from basic electrical engineering. Question level was easier. I hope you all have done this, that elimination of harmonics and the remaining questions also was easier, right. So simple factual questions, there is no such no much more calculation and all, whatever I have told you in class also. So thank you so much. So now, hello friends, we are going to discuss the advanced electronics portion of ESE. Okay, so very first question on the advanced electronics is, which one of the following technologies consume less power? So if we talk about the CMOS, bipolar and bi-CMOS, if we compare, so the options are CMOS, PMOS and NMOS. PMOS and NMOS are just MOSFET and CMOS is the complementary metal oxide semiconductor field effect transistor, we can say. So in the case of CMOS, the power consumption is less compared to NMOS and PMOS. Now what about the option A? Option A, surface mount technology. It is just packaging. तो हमने डिस्कस किया था क्लासेस में, आपने देखा होगा पैकेजिंग जिसमें सरफेस माउंट टेक्नोलॉजीज भी होती हैं, इसमें पीसीबी के ऊपर हम जस्ट उसको यूज कर लेते हैं. सो इट इज नॉट अ लॉजिक फैमिली. ओके, सो दीज आर द लॉजिक फैमिलीज PMOS, NMOS और CMOS, वेयर CMOS कंज्यूम्स लेस पावर. ओके, सो दिस इज द आंसर. सो ऑप्शन बी इज द आंसर फॉर दिस क्वेश्चन. ओके, now let us go for the next question on the advanced electronics. that is which one of the following require additional process step in their fabrication. So this question belongs to the resistor fabrication. So we can fabricate resistor by diffusion. Okay, so you know very well we can use bulk resistivity of any of the isolation region in the CMOS fabrication or bipolar fabrication as a resistor. Okay, so अब इसमें जो ऑप्शंस दिए हुए हैं थिन फिल्म रजिस्टर, एपिटेक्सियल रजिस्टर, जंक्शन रजिस्टर एंड पिंच रजिस्टर, अगर मैं बात करूं आपका तो ये क्या है एपिटेक्सियल रजिस्टर वगैरह, तो मैं देखूं जैसे सपोज मेरे पास जनरली हम पी टाइप सबस्ट्रेट हमारे पास अवेलेबल है. ओके, सो वी आर यूजिंग पी टाइप सबस्ट्रेट और इस पी टाइप सबस्ट्रेट के ऊपर मैं एपिटेक्सियल रेजिस्टेंस बनाने की कोशिश करता हूं. ठीक है, तो क्या करेंगे हम इस पी रीजन में मैं यहां पर एक एपिटेक्सियल लेयर ग्रो करूंगा जिसको मैं बोलूंगा एन टाइप एपिटेक्सियल लेयर. ओके, अब मैं क्या करूंगा इस एन टाइप एपिटेक्सियल लेयर को एज अ रेजिस्टेंस यूज करूंगा. हियर पी टाइप इज द सबस्ट्रेट, तो पी सबस्ट्रेट है आपके पास. अब आप क्या करते हो, दो साइड कॉन्टैक्ट लेते हो आप इसके. अगर मैं कॉन्टैक्ट लेके कोई भी बैटरी लगाऊं तो इलेक्ट्रॉन्स आपके फ्लो करेंगे इन दिस रीजन एंड दिस एन टाइप मटेरियल विल हैव सम रेजिस्टेंस दैट कैन बी यूज्ड फॉर द रेजिस्टेंस पर्पस. आपको पता है कि जब भी मैं कॉन्टैक्ट लेता हूं तो आपका एन टाइप मटेरियल है तो यहां पर हेवली डोपिंग करता हूं मैं. ओके, मैंने बताया था ओमिक कॉन्टैक्ट फॉर्मेशन कॉन्सेप्ट. ओके, अब देखो इलेक्ट्रॉन चार्ज पार्टिकल फ्लो करेंगे तो ये रीजन आपका यूज हो जाएगा एज अ रजिस्टर. इसको बोलते हैं एपिटेक्सियल रजिस्टर. ओके, तो ये आपका ऑक्साइड रीजन है, नो डाउट ये ऑक्साइड है आपका और यहां पर आपने कॉन्टैक्ट ले लिए, ये एपिटेक्सियल रजिस्टर होता है आपका. ठीक है, अब वो पूछ रहा है कि एडिशनल प्रोसेस स्टेप किसमें होगा. सिंपल सा कॉन्सेप्ट है, जो भी रेजिस्टेंस ना ऑक्साइड के नीचे वाला पोर्शन यूज करके बन रहा है ना उसमें एक्स्ट्रा आपके स्टेप नहीं लगेंगे. बिकॉज सपोज ये एन टाइप एपिटेक्सियल लेयर बनानी है आपको, ये कभी भी बना सकते हो आप. सपोज आप प्रोसेस में चिप के ऊपर कहीं पर भी फैब्रिकेशन कर रहे हो, ड्यूरिंग दैट यू कैन फैब्रिकेट दिस रीजन. अगर ऑक्साइड के ऊपर आप कुछ बनाते हो तो आपको अलग से स्टेप चाहिए रहेगा. तो ये आपका एपिटेक्सियल लेयर वाला केस था, बी वाला. ओके, पिंच रजिस्टर के केस में क्या होता है, पिंच रजिस्टर के केस में आपका यहां पर पी टाइप सबस्ट्रेट है. इस सबस्ट्रेट के ऊपर आप क्या करते हो, अगेन आपने एक एपिटेक्सियल लेयर बनाया. सपोज मैंने एन टाइप एपिटेक्सियल लेयर बनाया. इसमें मैं क्या करूंगा, अगेन पी टाइप मटेरियल की डिफ्यूजन करूंगा मैं, पी टाइप डिफ्यूजन, एंड देन यहां पर एक एन टाइप का एक मटेरियल क्या करूंगा मैं डिफ्यूज करूंगा, तो ये एन रीजन बना दूंगा मैं. अब यहां पर मैं ले लूंगा दो कॉन्टैक्ट. मैंने बताया अगेन जब भी कॉन्टैक्ट लो तो क्या कर दो, एन प्लस बना दो या पी प्लस बना दो, हेवली डोपिंग कर दो. अब यहां पर मैं बैटरी लगाऊंगा, अगेन चार्ज पार्टिकल फ्लो करेंगे दिस एन रीजन में, वो रेजिस्टेंस फील करेंगे. इस रेजिस्टेंस को बोलते हैं पिंच्ड रेजिस्टेंस. सो दिस रीजन इज जस्ट पिंच्ड रीजन. ओके, अगेन यहां पर अगर मैं ऑक्साइड की बात करूं तो ऑक्साइड आपका यहां पर अवेलेबल है. तो इसमें एडिशनल स्टेप नहीं चाहिए आपको. क्यों, क्योंकि ये जब आप भी डिफ्यूजन या कोई भी प्रोसेस कैरीड आउट कर रहे हो, चिप में आप कहीं पर भी कोई भी फैब्रिकेशन कर रहे हो, ड्यूरिंग दैट ओनली यू कैन फैब्रिकेट दिस डिवाइस. तो एक्स्ट्रा स्टेप नहीं है. बट इन द केस ऑफ ये आपका कौन सा है, पिंच रजिस्टर केस. ओके, जंक्शन रजिस्टर्स मींस कोई भी पीएन जंक्शन को एज अ रजिस्टर यूज कर लो आप. तो कहीं पर भी पीएन जंक्शन आप फैब्रिकेट कर रहे हो, बीजेटी फैब्रिकेट कर रहे हो आईसीज में, कहीं पर भी साइमल्टेनियसली उसी टाइम पर आप कहीं पर भी एक पीएन जंक्शन फैब्रिकेट कर सकते हो ड्यूरिंग दैट मास्क ओनली. तो एडिशनल प्रोसेस स्टेप नहीं रिक्वायर्ड है. लेकिन थिन फिल्म रेजिस्टेंस की बात करें जो कि इसका ऑप्शन करेक्ट है. ओके, ऑप्शन ए इज करेक्ट फॉर दिस क्वेश्चन. थिन फिल्म रेजिस्टेंस में क्या होता है आपका, सपोज आपके पास एक पी टाइप सबस्ट्रेट है. ओके, एनी सबस्ट्रेट, आप क्या करते हो इसमें, ये आपने इसका ऑक्सीडेशन कर दिया सबस्ट्रेट का, ये बन गया आपका SiO2 लेयर. ओके, इस SiO2 लेयर के ऊपर, इसके ऊपर आप क्या करोगे, इसके ऊपर 3D में बना दिया मैंने, आप एक थिन लेयर मेटल की डिपोजिट करोगे जिनको बोलते हैं थिन फिल्म रजिस्टर. अब आप यहां पर क्या बनाओगे, आप एक थिन फिल्म रजिस्टर बना दोगे. ये मेटल का है जिसके कांटेक्ट ले लिए आपने, इसको बोलते हैं थिन फिल्म रेजिस्टेंस. लेकिन इसके केस में क्या हो रहा है, आफ्टर ऑक्सीडेशन यू आर डिपोजिटिंग सम मेटल लेयर, उसके लिए आपको अलग से एडिशनल स्टेप की रिक्वायरमेंट होगी इन द केस ऑफ थिन फिल्म रजिस्टर. इसलिए आंसर ए इसका करेक्ट है. ओके, नाउ लेट अस गो फॉर द नेक्स्ट क्वेश्चन. In monolithic integrated circuit, the concentration of acceptor atoms in the region, okay, between isolation island will be. अरे भाई साहब, मैंने क्लास में पढ़ाया था आपको डिफरेंट आइसोलेशन, पीएन जंक्शन आइसोलेशन, लोकल ऑक्सीडेशन एंड सैलो ट्रेंच आइसोलेशन. ओके, आपको पढ़ाया था. अगर आप ध्यान करें पीएन जंक्शन आइसोलेशन का, तो कॉन्सेप्ट क्या था कि सपोज आपके पास एक सबस्ट्रेट है, मैंने ले लिया पी टाइप सबस्ट्रेट, और इसके अंदर मेरे बहुत सारे डिवाइसेस बना रहा हूं. एक चिप के अंदर बहुत सारे ट्रांजिस्टर, मॉस, ओके, बीजेटी हो सकता है, आपका पीएन जंक्शन हो सकता है. सपोज आपका यहां पर एक पीएन जंक्शन है, तो आप कैसे बनाओगे बेटा, ये एन टाइप और ये आपका पी टाइप. मान लो सपोज आप यहां पर बीजेटी बना रहे हो, एनपीएन ट्रांजिस्टर, ये लो भैया एन, ये लिया पी और ये ले लिया एन. अगेन यहां पर आपका एक बीजेटी हो सकता है, अगेन N और आपका ये P एंड दिस इज N। ये बीजेटी है आपका, सबस्ट्रेट पी टाइप है। मैंने क्या बोला था आइसोलेशन के लिए। अब बेटा ये आइलैंड हो गया, ये एक आइलैंड हो गया, ये दूसरा आइलैंड हो गया और तीसरा आइलैंड हो गया। इन दोनों के बीच में अगर मेरे को आइसोलेशन रखना है डिवाइसेस के बीच में, तो मेरे को क्या करना पड़ता था, रिवर्स वाइजिंग करनी पड़ेगी। किसकी? इस पीएन जंक्शन की। ये बॉडी है, बॉडी टर्मिनल का कैसे लूंगा मैं, ये बॉडी टर्मिनल, ये बीजेटी का अमीटर बेस कलेक्टर, ऐसे ये बीजेटी का अमीटर बेस कलेक्टर, ये पीएन जंक्शन का पी टाइप एन टाइप, बॉडी का ये बॉडी टर्मिनल बॉडी टर्मिनल। अब बेटा मैंने क्या बोला था, रिवर्स वाइज करना पड़ेगा आइसोलेशन के लिए। इस पीएन जंक्शन को कैसे रिवर्स वाइज करोगे, इस पी को किससे कनेक्ट कर लो, नेगेटिव से। अगेन इस पी को किससे कनेक्ट कर दूं, नेगेटिव से। लेकिन आपको पता है मैंने बोला था ना, डायरेक्ट मेटल को पी से कनेक्ट नहीं करते हैं, यहां पर क्या बनाना पड़ेगा, पी प्लस, ओमिक कॉन्टैक्ट के लिए पी प्लस। तो क्वेश्चन में ही पूछा है, ये दो आइलैंड को सेपरेट करने के लिए जो बीच में रीजन है उसकी डोपिंग क्या होती है, heavily doped compared to substrate. Okay, so आंसर क्या होगा, much higher than in the p type substrate. substrate में जो डोपिंग है उससे higher. So option A is correct for this question. तो ऑप्शन ए हो जाएगा इसका। Let us go for the next question. Okay, which one of the following statements is not correct for CMOS technology in comparison with bipolar technology? CMOS का bipolar से आपको कंपेयर करना है। आपको पता है CMOS के एडवांटेज कंपेयर टू बाइपोलर और बाइपोलर का एडवांटेज कंपेयर टू CMOS, उस पे ही क्वेश्चन है। तो CMOS टेक्नोलॉजी हैज लो स्टैटिक पावर डिसिपेशन, यस यही तो एडवांटेज है, ये करेक्ट है आपका। आपको देखना है नॉट करेक्ट स्टेटमेंट, तो ये स्टेटमेंट तो करेक्ट है। CMOS का स्टैटिक पावर डिसिपेशन कम होता है कंपेयर टू बाइपोलर। CMOS टेक्नोलॉजी हैज हाई इनपुट इंपीडेंस, हाँ ये तो भैया सही है। CMOS technology has high delay sensitivity to the load. Yes, it is also correct. CMOS technology has high output drive capability और high output drive current, इसको बोलते हैं फैन आउट। भाई साहब फैन आउट की अगर बात करें ना, तो ये CMOS वगैरह ना, इसके आउटपुट करंट कम है। मतलब CMOS का एक गेट बना है ना, उसके आउटपुट में आप उतने गेट नहीं कनेक्ट कर पाओगे जितने बीजेटी या बाइपोलर केस में कर पाओगे। बाइपोलर की ड्राइविंग कैपेबिलिटी ज्यादा होती है, फैन आउट ज्यादा होता है। तो नॉट करेक्ट देखना था, इसलिए इसका आंसर क्या हो जाएगा, डी। अगर मैं सी की बात करूं, सी का मतलब क्या, हाई डिले सेंसिटिविटी टू द लोड। मीनिंग इज दैट अगर CMOS टेक्नोलॉजी है, उसका आउटपुट क्या होता है, लोड कैपेसिटर होता है। अगर हम बात करें हाई डिले सेंसिटिविटी ऑफ द लोड, मतलब जो डिले आता है आपका केस में CMOS में, तो आपने पढ़ा होगा TPLH, अभी अभी गेट में भी आया ये क्वेश्चन ना, है ना, TPLH और TPHL आपने देखे होंगे, प्रोपोर्शनल होता है ये कैपेसिटिव लोड के, जो लोड है आउटपुट में। तो लोड चेंज होता है तो सेंसिटिविटी टू द डिले, है ना, बहुत ज्यादा हाई होती है। जितना CL चेंज होगा उतना डिले भी चेंज होगा। तो सी जो था वो करेक्ट था, बीजेटी केस में ऐसा नहीं होता है। ठीक, चलो तो आपका जो डी ऑप्शन है वो आपका करेक्ट है इसमें। ओके, लेट अस गो फॉर द नेक्स्ट क्वेश्चन। कंसीडर द फॉलोइंग स्टेटमेंट रिगार्डिंग MOS सर्किट डिजाइन प्रोसेस। MOS सर्किट्स आर फॉर्म्ड ऑन 4 बेसिक लेयर। हाँ आपको पता है MOSFET, ये आपका जो है ना वो लेआउट डिजाइन रूल से आपका रिलेटेड है, स्टिक डायग्राम से। आप देखें आप तो 4 लेयर क्या कौन कौन सी होती है, एन टाइप डिफ्यूजन, पी टाइप डिफ्यूजन, पॉलीसिलिकॉन एंड ऑक्साइड। ओके, सो एन डिफ्यूजन, पी डिफ्यूजन, पॉलीसिलिकॉन एंड मेटल, ये यूज करते हैं अपन, ये लेयर यूज करते हैं अपन MOSFET में या CMOS में, विच आर आइसोलेटेड फ्रॉम वन अनदर बाय थिन और थिक ऑक्साइड। थिन और थिक ऑक्साइड का यूज करते हैं फॉर आइसोलेशन पर्पस बिटवीन एन डिफ्यूजन रीजन, पी डिफ्यूजन रीजन, ओके, एंड पॉलीसिलिकॉन। तो ये करेक्ट स्टेटमेंट है आपका। थिन ऑक्साइड और थिनॉक्स मास्क रीजन इंक्लूड्स एन डिफ्यूजन, पी डिफ्यूजन एंड ट्रांजिस्टर चैनल, बिल्कुल सही बात है। थिन ऑक्साइड जो होता है मास्क रीजन इंक्लूड करता है आपका एन डिफ्यूजन को, पी डिफ्यूजन को एंड ट्रांजिस्टर रीजन को, ये भी करेक्ट है। थर्ड देखते हैं, पॉलीसिलिकॉन एंड थिनॉक्स रीजन्स इंटरैक्ट सो दैट अ ट्रांजिस्टर इज फॉर्म्ड वेयर दे क्रॉस वन अनदर। सिंपल लॉजिक है यार, ऑक्साइड के ऊपर आपका पॉलीसिलिकॉन डिपॉजिट करते हैं, अब जहां पर ये इंटरैक्ट कर रहे हैं तो उसी जगह पर तो आपका ट्रांजिस्टर बन रहा होगा, ट्रांजिस्टर का चैनल यार। तो करेक्ट है ये तो बिल्कुल एकदम। तो ऑल आर करेक्ट इन दिस केस। ओके, तो करेक्ट स्टेटमेंट देखना था, तो डी इज द करेक्ट आंसर। 1 2 3 सारे के सारे करेक्ट हैं इसमें। ठीक है, चलो जाते हैं आगे क्वेश्चन पे। ओके, so that's it, these are the question based on the advanced electronics. Okay, so thank you very much. Next teacher will discuss the respective subject.
वेलकम बैक। मैं दोबारा आपके सामने हूं। इस बार हम लोग मटेरियल साइंस जो आपका ईसी के पेपर 2 का पार्ट है उसको डिस्कस करने के लिए स्टार्ट करते हैं। इसमें आप खूब खुश हुए होंगे। जीएस में मटेरियल साइंस ने आपको दुखी किया, लेकिन ये टेक्निकल मटेरियल साइंस बहुत ही अच्छा एक्सपेक्टेड लाइन पर और ह्यूज वेटेज के साथ आया हुआ है। अगर आपने नोट्स और क्लास अच्छे से पढ़ी है तो ईच एंड एवरी क्वेश्चन आप कर सकते हैं। लेट अस स्टार्ट डिस्कशन दिस क्वेश्चन। फर्स्ट क्वेश्चन आपका आ रहा है कि ये द एटॉमिक पैकिंग फैक्टर ऑफ अ सिंपल क्यूबिक स्ट्रक्चर इज। अभी मैंने जो आरटीक्यू कराया था रिवीजन, सॉरी जो अभी आपका रिवीजन का कोर्स करवाया हुआ था यूट्यूब पर, उस पर भी इसको बताया था। आप जानते हैं एटॉमिक पैकिंग फैक्टर क्या होता है? एन नंबर ऑफ इफेक्टिव एटम्स पर यूनिट सेल डिवाइडेड बाय 4/3 पाई आर क्यूब अपॉन वॉल्यूम ऑफ द यूनिट सेल। ठीक है। अब सिंपल क्यूबिक के लिए इफेक्टिव नंबर ऑफ एटम्स 1 होते हैं, क्योंकि सिर्फ कॉर्नर्स पर होते हैं और कॉर्नर एटम 1/8 कंट्रीब्यूट करता है। और ए और आर के बीच में जो रिलेशन है ए इज इक्वल टू 2r या r इज इक्वल टू a/2। सो ये वैल्यूज अगर आप पुट कर दो 1 × 4/3 पाई r की जगह पर a/2 पुट कर देता हूं मैं, a/2 का क्यूब डिवाइडेड बाई a क्यूब। इसको सिंप्लीफाई करो तो दिस वैल्यू विल कम आउट 0.52। सो एटॉमिक पैकिंग फैक्टर फॉर सिंपल क्यूबिक क्रिस्टल स्ट्रक्चर इज 0.52। सो आंसर वुड बी गिवन बाय ऑप्शन सी। इसके लिए जो आंसर होगा वो ऑप्शन सी होगा। ठीक, बहुत सिंपल सा, याद भी होगा, आपको कैलकुलेट करने की जरूरत नहीं। सो हर किसी से बनना चाहिए। नेक्स्ट क्वेश्चन डिस्कस करते हैं। नेक्स्ट क्वेश्चन में कह रहा है कि फॉर सम सॉलिड मटेरियल्स ईच एटम पोजेसेस अ परमानेंट डाइपोल मोमेंट। ऑप्शन देखें। virtue of incomplete cancellations of electron spin and or oblique orbital magnetic moments, rotation and alignment with external field, the presence of external field, rotation of opposite direction with the external field। अगर आपको याद हो, यहां बात कर रहा है परमानेंट मैग्नेटिक डायपोल मोमेंट की। और परमानेंट डायपोल मोमेंट लिखा, लेकिन ऑप्शन से समझ में आ रहा है कि ही इज टॉकिंग अबाउट मैग्नेटिक डायपोल मोमेंट। अब मैंने आपको 3 कारण बताए क्लास में परमानेंट मैग्नेटिक डायपोल मोमेंट के। फर्स्ट, ऑर्बिटल एंगुलर मोमेंटम ऑफ इलेक्ट्रॉन, सेकंड इलेक्ट्रॉन स्पिन एंगुलर मोमेंटम, और थर्ड न्यूक्लियर स्पिन एंगुलर मोमेंटम। मैंने वहां पर यह भी आपको बताया हुआ है कि मोस्ट ऑफ द मटेरियल्स की मैग्नेटिक प्रॉपर्टीज में जो मेन रीजन है दैट इज इलेक्ट्रॉन स्पिन डायपोल मोमेंट। अब अगर कोई स्टेट पेयर्ड है तो उसके पास एक एंटी क्लॉकवाइज इलेक्ट्रॉन होगा और एक क्लॉकवाइज। तो एंटी क्लॉकवाइज के कारण अगर मैग्नेटिक डायपोल मोमेंट इस डायरेक्शन में, तो क्लॉकवाइज के कारण इस डायरेक्शन में, इसलिए एक दूसरे को कैंसिल कर देंगे, नेट मैग्नेटिक मोमेंट 0 हो जाएगा। लेकिन अगर अनपेयर्ड इलेक्ट्रॉन्स हो गया तो ये अनपेयर्ड इलेक्ट्रॉन आपका नेट मैग्नेटिक डायपोल मोमेंट में कंट्रीब्यूट करेगा। अब इस इंफॉर्मेशन के साथ इस क्वेश्चन को करते हैं कि फॉर सम सॉलिड मटेरियल्स ईच एटम पोजेसेस अ परमानेंट मैग्नेटिक डायपोल। तो परमानेंट मैग्नेटिक डायपोल के 3 कारण हैं, बट मेन कारण जो सबसे ज्यादा इफेक्टिव कारण है वो क्या है? इलेक्ट्रॉन स्पिन डायपोल मोमेंट। तो वर्च्यू ऑफ इनकम्प्लीट कैंसिलेशन ऑफ इलेक्ट्रॉन स्पिन ऑर्बिटल मैग्नेटिक मोमेंट। कंप्लीट कैंसिलेशन कब होगा? जब पेयर हो जाएंगे। तो पेयर होने पर तो नेट स्पिन डायपोल मोमेंट 0 हो जाएगा, लेकिन अगर पोजेस कर रहा है स्पिन डायपोल मोमेंट तो अनपेयर्ड होना चाहिए, और अनपेयर्ड के केस के लिए आपके पास एक परमानेंट मैग्नेटिक डायपोल मोमेंट आ जाएगा जो कि कैंसिल नहीं हुआ। सो इसके लिए आंसर हो जाएगा ऑप्शन ए। यहां पर आपको क्लास में याद होगा, मैं आयरन के लिए कैलकुलेट करके भी दिखाता हूं। नेक्स्ट चलते हैं। नेक्स्ट वन इज व्हिच वन ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट। ध्यान रखें, आपसे नॉट करेक्ट पूछ रहा है। व्हिच ऑफ द फॉलोइंग स्टेटमेंट इज नॉट करेक्ट रिगार्डिंग लैमिनेट्स। ऑप्शंस पढ़िए। पेपर रीइंफोर्स्ड लैमिनेट्स कैन बी यूज्ड इन थिकनेस रेंजिंग बिटवीन 0.2 mm एंड 50 mm। इस क्वेश्चन को देख करके कुछ लोग कंफ्यूज हो जाएंगे और लोगों को लगेगा कि बहुत डिफिकल्ट क्वेश्चन है। आप तीनों ऑप्शन पढ़िए। हो सकता है कि आपको 3 ऑप्शन ना आते हो, लेकिन एक ऑप्शन जो आंसर है वो जरूर आपको आता है। आपसे पूछ रहा व्हिच ऑफ द फॉलोइंग स्टेटमेंट्स इज नॉट करेक्ट। इसमें आप ऑप्शन सी पढ़िए, ग्लास रीइंफोर्स्ड लैमिनेट्स। मैंने आपको ग्लास रीइंफोर्स्ड फाइबर कंपोजिट्स पढ़ाए हैं, ठीक है। तो कह रहा कि ग्लास रीइंफोर्स्ड लैमिनेट्स मेक यूज ऑफ फिनॉल फॉर्मल्डिहाइड इम्प्रेग्नेंट एज एडहेसिव। अब जब भी हम लोग फाइबर ग्लास मटेरियल बनाते हैं तो हमारा जो मैट्रिक्स फेज होता है वो पॉलीमर होता है। मैट्रिक्स इट इज पॉलीमर, मैट्रिक्स फेज इज पॉलीमर। और जो रीइंफोर्समेंट करते हैं, रीइंफोर्समेंट, दिस रीइंफोर्समेंट फेज इज फाइबर। ये जो रीइंफोर्समेंट फेज है ये फाइबर है, बेसिकली ग्लास के फाइबर्स हैं। सो ग्लास फाइबर्स। रीइंफोर्समेंट को ही हम लोग इम्प्रेग्नेंट भी कहेंगे, इम्प्रेग्नेंट। इम्प्रेग्नेंट, इम्प्रेग्नेंट का मतलब वो चीज जो इंट्रोड्यूस की जा रही है। तो अब इस क्वेश्चन में कह रहा है कि ग्लास रीइंफोर्स्ड लैमिनेट्स में फिनॉल फॉर्मल्डिहाइड इम्प्रेग्नेंट है। गलत। फिनॉल फॉर्मल्डिहाइड एक पॉलीमर है और पॉलीमर मैट्रिक्स की तरह काम करेगा, इम्प्रेग्नेंट की तरह क्या काम करेगा, फाइबर ग्लास। तो आंसर जो हो जाएगा वो सी हो जाएगा। तो नॉट करेक्ट इस केस में सी है। बाकी के तीनों ऑप्शन हो सकता है कि आपको ना पता हो, क्योंकि इतना कौन याद करके रखता है कि पेपर का यूज कहां से कैसे क्या कर रहे हैं, बट करने लायक क्वेश्चन था। थोड़ा सा डिफिकल्ट, थोड़ा सोचने की जरूरत थी। बाकी मैंने फाइबर रीइंफोर्स्ड प्लास्टिक आपको कंपोजिट में पढ़ाया है, वहां से आप कर सकते हैं। नेक्स्ट आते हैं, नेक्स्ट क्वेश्चन अगेन वेरी सिंपल। व्हिच one of the following statements is not correct regarding mercury? अब ये थोड़ा फैक्चुअल क्वेश्चन है। एक आधे क्वेश्चन ऐसे आते हैं जो फैक्ट बेसिस क्वेश्चन होते हैं। इसमें आपसे पूछ रहा है कि मरकरी के लिए कौन सा स्टेटमेंट सही नहीं है। तो मरकरी इज ए हेवी सिल्वर व्हाइट मेटल, ये तो सही है। मरकरी आप सिल्वर के कलर का सिल्वरी व्हाइट मटेरियल होता है, ठीक है। द स्पेसिफिक वेट ऑफ मरकरी इज अप्रॉक्सिमेटली, अभी इस पर बात करेंगे। द मरकरी इज द ओनली मेटल व्हिच इज लिक्विड एट रूम टेम्परेचर, ये भी सही है, बिकॉज बाकी के सारे मेटल्स जो होते हैं वो क्रिस्टलाइन होते हैं, सॉलिड होते हैं। द बॉइलिंग पॉइंट ऑफ मरकरी इज 357 डिग्री सेंटीग्रेड, दिस इज ऑल्सो करेक्ट, ठीक है। जो इनकरेक्ट ऑप्शन है वो है बी, और आपको इनकरेक्ट ही सिलेक्ट करना था। मरकरी का स्पेसिफिक वेट जो होता है दैट इज अप्रॉक्सिमेटली 13.6 ग्राम पर सेंटीमीटर क्यूब, जबकि यहां पर कितना लिखा है, 31.6 लिखा है, लगभग 31.55 मींस 31.6। तो ये सही नहीं है। तो थोड़ा सा वैल्यू बेस्ड क्वेश्चन है, हो सकता है कि आपको डिफिकल्ट लगा हो, कोई बात नहीं, एक आध क्वेश्चन ऐसे आते हैं। अगले क्वेश्चन की तरफ चलते हैं। नेक्स्ट वन कह रहा है कि which one of the following what is the value of interplanar spacing for 2-3-1 plane of an FCC structure whose atomic radius is this? बहुत सिंपल क्वेश्चन। अभी जब आपका 2 दिन पहले मैं रिवीजन कोर्स करवा रहा था, हालांकि वो रिवीजन जीएस के लिए था, लेकिन क्वेश्चन सारे यहाँ टेक्निकल में पूछे गए। तो मैंने कहा था कि ब्रैग्स लॉ में जो आपका डी है वो इंटरप्लेनर स्पेसिंग है, और क्यूबिक क्रिस्टल स्ट्रक्चर के लिए DHKL, where HKL is your lattice your Miller indices for the plane, this is given as A upon under root h स्क्वायर प्लस k स्क्वायर प्लस l स्क्वायर, जहां पर a आपका एज लेंथ है, क्यूब की एज लेंथ। अब FCC के लिए एज लेंथ क्या होता है, a इज इक्वल टू 2√2r, ये FCC के लिए रिलेशन है, हम सभी जानते हैं, ठीक है। r इज इक्वल टू √2a/4 या a इज इक्वल टू 2√2r। तो a की अगर ये वैल्यू पुट कर दो 2√2 एंड इंटू r की वैल्यू रेडियस दी हुई है 0.125 नैनोमीटर, तो ये मिल जाएगा। और h की वैल्यू यहां पर कितना होगी, HKL दैट इज 231, तो h इज इक्वल टू 2, k इज इक्वल टू 3 एंड l इज इक्वल टू 1। If I put all these values, so 2√2 into 0.125 nanometer divided by under root h square is 4 plus k square that is 9 plus l square that is 1, ठीक। इसको सिंप्लीफाई कर लीजिए, इसको सिंप्लीफाई करेंगे तो ये आंसर आएगा 0.094 नैनोमीटर। किस ऑप्शन में दिया है 0.094 नैनोमीटर, दैट इज गिवन इन ऑप्शन सी। सो राइट चॉइस फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन सी। स्ट्रेट फॉरवर्ड था, थोड़ा सा कैलकुलेशन करना था, इतना आप कर सकते हो। सो आंसर इज गिवन बाय ऑप्शन सी। नेक्स्ट क्वेश्चन आते हैं, क्विकली फटाफट देखते चलते हैं। बहुत सिंपल मटेरियल साइंस आपसे पूछी गई है। हालांकि जीएस मटेरियल साइंस ने आपको आज दुखी किया, लेकिन ये मटेरियल साइंस बहुत सिंपल और बहुत खुश करने वाली है। व्हेन अ बार इज सब्जेक्टेड टू अ रैपिडली अल्टरनेटिंग मैग्नेटिक फील्ड, देयर इज रैपिडली अल्टरनेटिंग मैग्नेटिक फील्ड, देयर इज रैपिड एक्सटेंशन एंड कॉन्ट्रैक्शन इन द लेंथ ऑफ द बार, दिस फिनोमेना इज नोन एज। डिफिनीशन लिखाता हूं मैं, मैग्नेटोस्ट्रिक्शन की डिफिनीशन क्या है कि चेंजेस इन द डायमेंशन ऑफ अ magnetic material when the material is subjected to an alternating field, या when the material is put into a magnetic field. So this is nothing but the definition of magnetostriction, पहली लाइन जो आपको लिखाते हैं। So answer would be given by option सी। कोई मैग्नेटिक मटेरियल अल्टरनेटिव फील्ड में रखा जाएगा तो उसकी डायमेंशन में चेंज आते हैं। मैं वेरियस टाइप्स ऑफ मैग्नेटोस्ट्रिक्शन आपको पढ़ाता हूं, लॉन्गिट्यूडनल, ट्रांसवर्स, वॉल्यूम एटसेट्रा, लेकिन यहां जस्ट डिफिनीशन की जरूरत थी। सो दिस इज ऑप्शन सी, क्वेश्चन नंबर 6। क्वेश्चन नंबर 7 की तरफ चलते हैं। क्वेश्चन नंबर 7 में आपसे पूछ रहा है कि द मटेरियल कंपोज्ड ऑफ C60 मॉलिक्यूल दैट कंटेन्स 60 कार्बन एटम्स इन अ नेटवर्क ऑफ sp2 बॉन्डिंग व्हिच फॉर्म्स अ स्फेरिकल स्ट्रक्चर। इसको अगर आप नहीं कर पा रहे हो तो आपको बहुत दुखी होना चाहिए। क्योंकि फलरीन, मैं जब आपको कार्बन पढ़ाता हूं तो कार्बन के 3 चीजें पढ़ाता हूं, डायमंड, ग्रेफाइट एंड फलरीन। फलरीन में हम लोगों ने क्या कहा था कि बॉल जैसा शेप, हॉलो स्फेरिकल बॉल जैसा शेप होता है जिसमें 60 कार्बन एटम्स एक दूसरे के साथ जुड़े होते हैं, कुछ हेक्सागन और कुछ पेंटागॉन्स बनाते हैं, 20 हेक्सागन्स और 12 पेंटागॉन्स बनते हैं। तो ये किसकी बात कर रहा है? C60 मॉलिक्यूल इज नथिंग बट बकमिंस्टर फलरीन। सो आंसर फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन ए। नेक्स्ट आते हैं, next one is the electronic properties of nanotube could be changed between metallic and semiconducting simply by, ये थोड़ा आपको लग सकता है कि डिफिकल्ट था लेकिन थोड़ा सा सोचने की जरूरत। कार्बन नैनोट्यूब में मैंने क्या कहा था कि कार्बन नैनोट्यूब, नैनोट्यूब का मतलब कार्बन नैनोट्यूब, CNT जो होती हैं इनका डायमीटर इज लेस देन 100 नैनोमीटर, लेंथ कुछ भी हो सकती है, L/D रेशियो ग्रेटर देन 1000 है। तो बेसिकली CNT में जो डायमेंशन हम रिस्ट्रिक्ट कर रहे हैं वो कौन सी डायमेंशन है? डायमीटर रिस्ट्रिक्ट कर रहे हैं, उसे नैनो रेंज में रख रहे हैं। तो अगर आपको प्रॉपर्टी चेंज करनी है तो आपको डायमीटर चेंज करना पड़ेगा। तो आप इसको कंडक्टिंग, सेमी कंडक्टिंग या कुछ भी इलेक्ट्रिकल कंडक्टिविटी दे रहे हो तो उसके लिए आपको डायमीटर में चेंज लेकर के आना पड़ेगा। सो आंसर क्या होना चाहिए? द ट्यूब डायमीटर। ठीक है, सो बी वुड बी द राइट चॉइस फॉर दिस क्वेश्चन। थोड़ा सा सोचने की जरूरत थी। CNT को डिफाइन करते वक्त मैं क्या कहता हूं, जैसे मैंने नैनो मटेरियल में आपको कहा था कि वन डायमेंशन मस्ट बी लेस देन 100 नैनोमीटर। तो जो डायमेंशन आपकी लेस देन 100 नैनोमीटर में होगी वही कैरेक्टरिस्टिक डिफाइन करेगी। सो लेस देन 100 नैनोमीटर में यहां पर कौन सी डायमेंशन होगी? डायमीटर। सो डायमीटर चेंज करने पर इसका कैरेक्टर चेंज हो जाएगा। सो कैरेक्टरिस्टिक डिफाइन करने के लिए डायमीटर की जरूरत है। नेक्स्ट आते हैं, नेक्स्ट क्वेश्चन इज at very low temperature where resistivity of certain materials abruptly plunges from a finite value to one that is virtually zero and remains upon further cooling is, अरे भाई रेजिस्टिविटी आपकी फाइनाइट वैल्यू से 0 हो जा रही है, याद है ना ये कर्व आपको, और पहली लाइन हम लोग यहां लिखते हैं ये, दिस इज सुपर कंडक्टिंग स्टेट एंड दिस इज नॉर्मल स्टेट। तो रेजिस्टिविटी जिस टेम्परेचर के बिलो होती है इसको मैं नाम देता हूं क्रिटिकल टेम्परेचर, ट्रांजिशन टेम्परेचर, ट्रांजिशन टेम्परेचर, क्रिटिकल टेम्परेचर या ट्रांजिशन टेम्परेचर, या इसे ओन्स टेम्परेचर भी कहते हैं, ओन्स टेम्परेचर। ये 3 नाम है, आपके पास कौन सा नाम है? सी। सो आंसर फॉर दिस क्वेश्चन वुड बी गिवन बाय सी। सो क्रिटिकल टेम्परेचर इसका आंसर होगा, जहां पर वेरी फाइनाइट लो फाइनाइट रेजिस्टिविटी से आप चले आएंगे नीचे और जो रेजिस्टिविटी आपकी 0 हो जाएगी बिलो द क्रिटिकल टेम्परेचर। नेक्स्ट क्वेश्चन की तरफ चलते हैं। नेक्स्ट क्वेश्चन क्विकली, फटाफट। नेक्स्ट क्वेश्चन है, सुपर कंडक्टिंग मटीरियल्स आर यूज्ड इन व्हिच ऑफ द फॉलोइंग एप्लीकेशन। एप्लीकेशंस जहां लिखाता हूं वहां पर आपको देखो 3 ही 4 एप्लीकेशन लिखाता हूं, मैग्नेटिक लेविटेशन में, मोटर्स में, हाई एनर्जी फिजिक्स में, एंड उसके बाद MRI में, मैग्नेटिक रेजोनेंस इमेजिंग में। पहला ऑप्शन देखो, मैग्नेटिक रेजोनेंस इमेजिंग एकदम सही आंसर है। ठीक है, कह रहा है कि व्हिच ऑफ द फॉलोइंग आर एप्लीकेशन, मैग्नेटिक रेजोनेंस स्पेक्ट्रोस्कोपी, इसके बाद में कर लेंगे। हाई स्पीड स्विचिंग डिवाइसेस, जी हां, क्रायोट्रॉन याद होगा ना, क्रायोट्रॉन मैंने आपको लिखाया हुआ है माइक्रोवेव स्विचेज के तौर पर। माइक्रोवेव स्विचिंग मींस वेरी हाई फ्रीक्वेंसी स्विचिंग, हाई स्पीड स्विचिंग। ठीक, हाई स्पीड मैग्नेटिकली लेविटेटेड ट्रांसमिशन। तो भाई 1, 3, 4 मैंने आपको लिखा दिया था, तो अब उसके हिसाब से आपके पास यही एक ऑप्शन है, यानी 2 नहीं भी लिखा है तो भी इस आंसर क्या है? सही है, 2 में भी यूज हो रहा है। तो इस तरह से सफिशिएंट इंफॉर्मेशन आपको क्लास में दी गई थी, इसका आंसर डी हो जाएगा। दीज 3 हमने क्लास में नोट्स में आपको लिखाया है, चौथा अगर नहीं भी लिखा है तो ऑप्शन के हिसाब से आपको पता है कि चौथा भी आंसर सही हो रहा है। नेक्स्ट आते हैं, नेक्स्ट वन कह रहा है व्हिच ऑफ द फॉलोइंग आर नॉट द प्रोडक्शन मेथड्स फॉर कार्बन नैनो ट्यूब्स। बहुत सिंपल सा लॉजिक लगाना था इसमें। ये जो क्रॉल्स्की मेथड है आपको एडवांस इलेक्ट्रॉनिक्स में बताया गया होगा कि ये सेमीकंडक्टर्स के प्रोडक्शन के लिए यूज होता है। तो अगर सेमीकंडक्टर के प्रोडक्शन के लिए यूज हो रहा है तो इसका मतलब नैनो स्केल पर ये हमारे काम का नहीं है, और हमसे क्या कह रहा है कि नैनो ट्यूब की प्रोडक्शन के लिए। तो नैनो ट्यूब की प्रोडक्शन क्रॉल्स्की मेथड से नहीं की जा सकती, तो थर्ड वाले को काट दो। 3 जहां है वो कट गया, बचा क्या? 1 और 2। ठीक है, इलेक्ट्रिक डिस्चार्ज मेथड, लेजर वेपराइजेशन मेथड, इन दोनों का यूज करते हैं और इनसे बनाया जा सकते हैं। तो यहां ऑप्शन एलिमिनेशन का यूज करके आप इसको कर सकते हो। तो इसके लिए आंसर हो जाएगा आपका ऑप्शन ए। नेक्स्ट आते हैं, नेक्स्ट में which one of the following temperatures exist for the magnetic moments of a ferromagnetic material which becomes substantially diverse in orientation that the material becomes non-magnetic। मजाक है भाई इस तरह के क्वेश्चन। आप देखो क्यूरी टेम्परेचर के बिलो पैरेलल अलाइनमेंट होता है और एबव क्यूरी टेम्परेचर जैसे आप जाते हो ग्रेटर देन टीसी पर तो आपका मैग्नेटिक मोमेंट क्या हो जाता है, रैंडमली ओरिएंटेड, डायपोल्स आपके रैंडमली ओरिएंटेड हो जाते हैं। मटेरियल कन्वर्ट्स इनटू पैरामैग्नेटिक मटेरियल्स। तो किस टेम्परेचर की बात कर रहा है, क्यूरी टेम्परेचर की। सो फेरोमैग्नेटिक मटेरियल्स के जो पैरेलल अलाइनमेंट है डायपोल्स का वो रैंडम ओरिएंटेशन में कन्वर्ट हो जाएगा और किस टेम्परेचर पर कन्वर्ट होगा, क्यूरी टेम्परेचर पर। वेरी सिंपल, आपके नोट्स में लिखा है और बहुत इस पर डिस्कशन होता है, मैं डेरिवेशन भी कराता हूं। सो बहुत ही एलिमेंट्री टाइप ऑफ क्वेश्चन है, यू कैन इजीली डू इट। नेक्स्ट क्वेश्चन, नेक्स्ट क्वेश्चन में कह रहा है कि सम ऑफ द कॉमन एंड फेमिलियर पॉलीमर्स आर पॉलीएथिलीन, नायलॉन, पॉलीविनाइल क्लोराइड, पॉलीकार्बोनेट, पॉलीस्टाइरीन एंड सिलिकॉन रबर। आपके जो जीएस वाली बेसिक्स ऑफ मटेरियल साइंस की बुक है ना, थर्मोप्लास्टिक के जितने भी एग्जांपल हैं उन सारे के नाम लिख दिया है इसमें, ऑलरेडी आपके पास अवेलेबल है, आप जानते हैं कि सारे प्लास्टिक्स हैं, ठीक है। पॉलीमर्स इंक्लूड द फेमिलियर प्लास्टिक एंड रबर मटेरियल। जी हाँ, ये भी सही है। पॉलीमर्स बेसिकली क्या है, पॉलीमर्स में आपके पास कुछ प्लास्टिक्स हैं, फेमिलियर प्लास्टिक जैसे पॉलीएथिलीन, बेकेलाइट एक्सेट्रा, और रबर्स मैं आपको क्वेश्चंस वगैरह भी कराता हूं क्लास में, नेचुरल रबर, सिंथेटिक रबर, तो ये सारे रबर, तो ये सारे किसके अंदर आते हैं, पॉलीमर के। लेकिन ये दोनों स्टेटमेंट इंडिविजुअली ट्रू हैं, ऐसा नहीं कि ये स्टेटमेंट इसकी एक्सप्लेनेशन दे रहा है। यहां पर कुछ एग्जांपल दिए गए, यहां पॉलीमर्स के अदर एग्जांपल दे दिए गए। सो दिस स्टेटमेंट इज नॉट रीजन फॉर दिस स्टेटमेंट। तो मेरे हिसाब से इस क्वेश्चन के लिए जो आपको आंसर देना चाहिए वो आंसर देना चाहिए बी फॉर बॉम्बे। सो आप 146 का आंसर देंगे बी फॉर बॉम्बे, ठीक है। सो बस मटेरियल साइंस में इतने ही क्वेश्चन थे, एक आध क्वेश्चन थोड़े बहुत स्लाइटली थे जिनमें दिमाग लगाना था, बाकी सारे आपके नोट्स से थे। तो जीएस मटेरियल साइंस में थोड़ा सा आप दुखी हुए होंगे, मैं भी थोड़ा डिसअपॉइंट हुआ कि बहुत ही अनएक्सपेक्टेड एरिया पूछा गया था। लेकिन टेक्निकल मटेरियल साइंस में आपको बहुत खुश होना चाहिए, सब कुछ आपके नोट्स से था, आप लगभग सारे क्वेश्चन कर सकते थे। बेस्ट विशेष। जीएस में आप ये मान के चलिएगा कि अगर पेपर डिफिकल्ट था तो सबका डिफिकल्ट था, थोड़े कम मार्क्स आएंगे तो आपके भी कम आएंगे, कोई बात नहीं। टेक्निकल में अच्छा स्कोर करिए, अच्छा हो रहा है। सो मेरी तरफ से आज का सेशन यहीं पर एंड करते हैं, दूसरे टीचर आकर के दूसरा सब्जेक्ट लेंगे। थैंक यू।
Yeah. Good evening, students. Welcome to measurements. Yeah, right. This time around 11 questions came in 12 questions came in measurements. EC measurement questions are very good. Few questions are a little bit tougher, but it's okay, no problem. We can see. Yeah, first question. Yeah, read the first question. Question number 37. Fine. The output of LVDT is connected to a 5 volts voltmeter through an amplifier whose amplification factor is given 200. An output of 2 millivolts appears across the terminals of LVDT. Fine. Terminals of LVDT when the core moves through a distance of 0.5 mm. When the core moves through a distance of 0.5 mm. Fine. But what they are giving, tell me? The millivoltmeter scale has 100 divisions. This is more important. A millivoltmeter scale has 100 divisions, right? And scale can read up to 1/5 of one division. 1/5 of one division. The sensitivity and resolution of the instrument. Very good. Okay. Can we able to solve? Yeah. Just you look at. Yeah. This is your LVDT. How the LVDT is connected? It is connected through amplifier. Yeah, amplifier gain is given. How much amplifier gain? 200. Amplifier gain is given as 200, and this is measured by voltmeter. Yeah, but what is the voltmeter full scale value? 0 to 5 volts. Voltmeter full scale value 0 to 5 volts. Fine. But how many number of divisions? Yeah, full scale value 5 volts, 100 divisions. Total number of divisions are 100. Is it clear? Yeah, total number of divisions are 100 is given. But what is the sensitivity? They are asking. So how we can write it sensitivity? Tell me. The sensitivity of LVDT is equal. Yeah, what is the sensitivity of LVDT? Generally voltage upon, right, your output is voltage, input is displacement, we can able to say, right? Output is voltage, input is displacement. I think V naught upon X. How much voltage is given, tell me? 5 volts voltmeter through an amplifier, right? Amplification factor is 200, output voltage 2 millivolts. What is the output voltage? Is given as 2 millivolts. Therefore sensitivity equal to, what you can write? Yeah, sensitivity of voltmeter is equal to V naught upon X. Yeah, 2 millivolts upon, what is the core distance? 0.5 mm. 2 by 0.5. Just you can do the calculation part. 2 by 0.5 is how much? 4 millivolt per mm. Right, this is the sensitivity. This is the sensitivity of LVDT. But what is the overall sensitivity? By overall sensitivity, it is looking like cascaded system, right? Whenever it is looking like cascaded system, in a cascaded system, the overall sensitivity equal to sensitivity of LVDT into gain factor. Gain is amplifier gain or simply gain, you can write it. Fine, amplifier gain. How much you can write it, tell me? Sensitivity of LVDT, already you got it, 4 millivolt per mm. Amplifier gain is 200. So now what we can write it? Overall sensitivity 800 millivolt per mm, correct? This is the overall sensitivity. I think we can sense the options, right? We can able to sense the options. 800 millivolts is nothing but, I think, which option may be correct? Only one I solved. 800 millivolts. I think answer may be either B or C. Just you can check it, no issue. Okay. Now resolution. But what is the resolution? Tell me. Generally, What is the meaning of resolution? The smallest value of change in input quantity we can able to detect properly. What is the total number of divisions? 100. What is the full scale value? 5 volts. But the scale can able to read, the meter can able to read 1/5 of scale. Therefore, can we write like this? Resolution equal to resolution is equal to V minimum upon overall sensitivity. V minimum upon overall sensitivity. But what is the V minimum? Tell me. 1/5 of scale can able to read properly. Can you write like this here? 1 division. How much 1 division? 1 division is equal to, there are 100 divisions are there, 5 volts full scale value, 5/100. 1/5 of scale can able to read properly. 1/5 of 1 division. 1/5 of 1 division is how much? Can you write like this? This 5 cancel upon 100. We can able to do like this directly. Shall I write here? What is the V minimum? Tell me. V minimum is equal 1/5 of 1 division upon overall sensitivity. Fine. Already you know 1/5 of 1 division is nothing but this is 1 upon 100 only, or 0.01. Okay. Now can we write here 1/5 into 5 upon 100. Overall sensitivity 800 millivolt per mm. Now simplify. If you have done simplification, now simplify it. How much you will get? 1 upon 100 into 800 into millivolt per mm. Simplify this value. Milli, this milli is nothing but just you can write it directly instead of milli. Okay. Milli, remove it. Directly you can write it into 10 to the power of -3. If you have done simplification part, just you do the simplification. Final answer, already I have done the calculation, 0.0125 mm. Mm goes to numerator. It's nothing but how much? 12.5. 12.5 into 10 to the power of -3 mm. Hence, which is the correct option? I think option C. Approximate answer available here, option C. I don't know, some printing mistake might be happen. Answer may be either B or C, but if you are going to check it here, which is the better option? Available option is option C is the correct answer. This is a printing mistake only, 12.5 into 10 to the power of -3 mm. Now next we can go to next question. The coil of a recording ammeter is 65 mm long, 25 mm wide. Yes. Directly can we able to solve it? Very simplified manner. But what they given? Tell me. Coil area of cross section is given. What is the coil area of cross section? Tell me. Just you read it. Coil area of cross section is 65 mm by 25 mm long. Convert into meters. 65 into 25 into 10 to the power of -6 meters. This is nothing but it's like a coil area of cross section, length into width only. It's not required. Just you can write it otherwise. Rated current is given. How much rated current? 10 milliamperes is nothing but 0.01 amperes. Correct? This is the current. Flux density in the air gap, B also given. How much? 0.0046 Weber per meter square. Clear? A damping constant is given. Is it required damping constant? Very small value, it is negligible only. Damping constant not required. Moment of inertia also given, this is also negligible only, very small values. So that you can get approximate answer, don't worry. Spring constant is given. How much spring constant? 0.016. spring constant Kc 0.016 Newton meter per radian. This is important. Units are important here. Okay. Yeah, Coulomb friction is given. It's not required again. The number of turns of a coil to produce a deflection of 100 degrees. That is important. What is the deflection? Tell me. The deflection of, to produce deflection of 100 degrees. But convert into meters. 1 degree is equal to pi by 180 radians. Yeah, 1 degree is equal to pi by 180 radians. It's fine. Yeah, I think we know very well. At steady state, what we can write it? At steady state, yeah, deflecting torque is equal to controlling torque. Just equating together. Kc into theta is equal to, what is the deflecting torque in PMM's instrument? Bina. We studied many times, right, in the regular class, Bina. Kc into theta is equal to Bina. Okay. Now, I think they given everything. Once they given everything, just you substitute here. Yeah, Kc value how much? Tell me. 0.016 Newton meter per radian. Units are important here, because you are going to do this type of mistakes. Newton meter per radian. Deflection theta 100 degrees, right, 100 into pi by 180 radians. Fine. Bina, B value is how much? 0.0046 Weber per meter square. Fine. I current 0.01 10 milli, right. Area of cross section, 65 into 25 into 10 to the power of minus 6 meter square, right, into number of turns is n. Fine, number of turns is n. Is it clear? Now just you check the calculation. Meter square, this meter square cancel, here radian cancel. Now do the calculation on left side. If you have done the calculation on left side, the left side value is around 0.02792. 0.02792. This is on left side calculation. Right side, do the calculation work. I have done already. The right side calculation work is 0.07475. 0.7475 into 10 to the power of minus 6. Yeah, into n. But what I require here? N. The number of turns of a coil, where n is called number of turns of a coil. N is equal to, what you can write it? Tell me. 0.2792. 0.07475 into 10 to the power of minus 6. Yeah, do the simplification, you will get a value around 37.3511.7. Yeah, approximate answer available. Please you check it. I think option A is correct. The approximate answer is available because we neglected the damping constants. Correct? So A is the correct answer. Is it clear? Right. Now we will move to next question. Okay. What is the next question? Tell me. Read it, all of you. I think it's good. What are they given? Tell me. Consider the following statements regarding data acquisition system, DAS. Yeah. What is this data acquisition system? DAS is a group of electronic devices. They are connected in a sequential manner to perform a specific measurement. Understood? Therefore, digital data acquisition system, digital data generally used for wide frequency range. It's correct. Correct or not? Okay, used for wide frequency range. Fine. Okay, correct. Analog data acquisition systems are more complex than digital systems. It's absolutely correct. That is the reason only nowadays everywhere we will go for digital data. Storage of digital data is easy, less memory also. Right, it's correct. digital data acquisition systems are used when physical quantity is being monitored, has narrow bandwidth. I think so. The effective answer is 192, right? So more correct answer is 192, correct. Hence option A is correct answer. Okay. Yeah, next question. A wave analyzer. What is this wave analyzer? Wave analyzer is also known as spectrum analyzer. Usually in the DAS topic we are going to use we are going to discuss in the regular class different types of analyzers: harmonic distortion analyzer, wave analyzer, spectrum analyzer, right? So wave analyzer, in the wave analyzer usually selective level meters, either voltage type. If you are doing voltage signal analysis, voltage selective meter. If you are using current signal analysis, current selective meter we are going to use. So obviously hence option A is the correct. No need to check other options directly, because modulation analyzer different, audio analyzer is different, precision receiver is different. Hence we can conclude option A. Okay. Yeah. What is the displayed rise time? What is the displayed rise time? Approximately when a pulse wave form with a rise time of 21 nanoseconds is applied to an oscilloscope. Upper cutoff frequency is given. What is upper cutoff frequency? 50 megahertz. Right. Rise time how much is given? Tell me. Yeah, they have given a rise time of how much? Can I calculate like this? Given that, look at please. Right. What they given? Tell me. Given that TR rise time 21 nanoseconds, corresponding rise time. Suppose if I am calculating the frequency, right, 1/21 nanoseconds. Right. Do this calculation work. 1/21 nanoseconds. How much? Tell me. Right. 1/21. Suppose if you have done calculation, this value is around 47.62 megahertz. 47.62 megahertz. Yeah. At this particular rise time, the corresponding frequency is 47.62 megahertz. But what is the upper cutoff frequency? Tell me. Upper cutoff frequency is given how much? 50 megahertz. Hence what we can conclude? Tell me. Right. At this time, or at this rise time, the given frequency is 47.62 megahertz. I think which is this frequency is less than the upper cutoff frequency, less than the upper cutoff frequency of 50 megahertz. Hence it can read, oscilloscope can read, or it can display, hence it can display, right, how much it can display or read nearly around. So can we write like this? It can display nearly 21 nanoseconds only. It's like logical question, right? Approximately here, can I write the given option is 22. The given option available is 22 nanoseconds. Actually, it will read around this 21 nanoseconds only. Okay. So hence available option, which is the correct option? It's option B is the correct, 22 nanoseconds, right? Actually 21 only, approximate answer is available 22. Okay. Next, we will go for next question. What is the next question? Tell me. Yeah, it's a good question. A 4 strain gauges are mounted. Yeah. So tell me, 4 strain gauges are mounted. A simple flat tensile specimen, arranged for complete temperature compensation and maximum sensitivity when connected to forearm bridge, okay, right. And 18 to 10 to the power of 5 ohms calibration resistor shunted across. This is called calibration resistor. Shunted across one of the strain gauge. Very good. One of the arm. If the gauge resistance is 188 ohms and the gauge factor also given GF 1.22. So what is the given data? Tell me. Right. Given that gauge resistance RG. How much gauge resistance RG is given as 188 ohms. Gauge factor also given. How much gauge factor? 1.22 is given. Calibration resistance R shunt is given. This is the calibration resistance, shunt resistance. How much? 8 into 10 to the power of 5 ohms. Right. How the bridge is formed? Can we draw the bridge here? The bridge is like this. This is RG. Fine. This is the bridge we are drawing. RG. Fine. But in one of the arm strain gauge, this is RG again. Okay. This is RG. But what they given? Tell me. In one of them shunted across. It's like this. How they shunted? With the help of some switch arrangement. Yeah, with the help of switch arrangement. What is the shunt resistance is given? Tell me. The shunt resistance 8 into 10 to the power of 5. This is RSH. Now when switch is closed, this is switch arrangement. Yeah, when switch is closed, what will happen? Just you look at. Fine. Yeah, it is excited by battery. It's a temperature compensation technique. It's a bridge. Fine. Okay. Yeah, it's a battery, not required. Fine. When switch is closed, suppose right, when switch is closed, what is the effective resistance? RSH dash you can calculate. I think when switch is closed, RSH parallel with RG. RSH parallel with RG. But what I require? Change in resistance I require. So R effective is nothing but RSH parallel with RG. Right. Change in resistance delta R is equal to R dash minus R. This RSH parallel with RG, R effective is also nothing but R dash assume. This is assume R dash. Directly can we write here? Delta R is equal to RSH into RG. This value R dash is nothing but RSH into RG upon RSH plus RG. Fine. It's clear. Directly you can substitute here. Right. Minus R. This equation you can use just. If you are using here, now you can solve it here. Okay. Use this equation and calculate the value. How much you will get? Tell me. Delta R is equal to RSH value is how much? 8 into 10 to the power of 5. This is RG value 188 ohms. Right. Minus RG minus 188. Simplify this calculation part, everybody. Right. After doing simplification, yeah, you will get the value. This is around 187.95 minus 188. Look at this is 187.95 minus 188. So therefore finally the delta R value minus 0.04417 0.04417 ohms. Yeah, this is your delta R. Yeah, once you got delta R, it is easy. What is the definition of gauge factor? Tell me. The definition of gauge factor, can we write like this? gauge factor is equal to, defined as the ratio of unit change in resistance to the applied strain. Okay, what is applied strain is nothing but epsilon, but here I require epsilon only. It's nothing but unit strain, delta R by R upon GF. Right, directly substitute delta R, you got it 4417, right. Okay, upon R value 188, GF value 1.22. How much given GF value? Right, GF value 1.22 is given. Clear? Now simplify this work. If you have done proper simplification, how much you are going to get it? Epsilon value minus 192.57 minus 192.57 into 10 to the power of minus 6. Yeah, but it's a quarter bridge. So whenever it's a quarter bridge, for quarter bridge, generally quarter means by 4, full bridge means as it is, half bridge means by 2, quarter bridge here. So for quarter bridge, epsilon is equal to, or strain for quarter bridge is equal to minus 192, this is for quarter, 192.57 into 10 to the power of minus 6 divided by 4. Yeah, simplify, minus 48 point, check this calculation, minus 48.14 into 10 to the power of minus 6. Okay, this is the final answer. So hence which option is correct? Look at please all of you. Hence option C is the correct answer. Okay, yeah. Go to the next question. Yeah, what is the next question? I think it's very simple only. Direct class notes question. A 0 to 200 volts voltmeter has guaranteed accuracy GAE. How much? 0 to 200 volts. This is full scale value. GAE how much given? Plus or minus 1% of full scale deflection. But I told you many number of times in the regular class, whenever plus or minus 1% of full scale is there, full scale is how much? 200 volts. Right, whenever GAE 1% of, whenever GAE 1% of full scale is there, so limiting error is equal to, I think shall I write directly, limiting error is equal to full scale value upon reading. What is the reading? Tell me. How much reading? 150 volts. Yes, you can convert 1% of 200. How much 1% of 200? 2 volts only. Plus or minus of 2 volts, 1% of 200. Okay, reading value is how much? 150 plus or minus 2 volts. So percentage of limiting error is equal to, directly you can do full scale value 200 volts upon reading value. What is the reading value? 150. Simplify this value. Right, 200 upon 150. How much you are going to get it? Approximate value, tell me. So minus 1.33, minus 1.33 percentage. Hence, which option is correct? So please tell me. Minus 1.33. Hence, option D is correct. Okay. Go to the next question. Yeah. What is the next question? Tell me. Now, please read it. A voltage has true value. I think is given. What is the given? Tell me. Voltage has true value 1.55 volts. True value 1.55 volts. Okay. Voltage has true value 1.55 volts. Indicating instrument. Scale range 0 to 2.5 volts. Right. Shows a voltage of. What is mean by shows a voltage? Measured value 1.48 volts. Fine. Relative error. Directly you can calculate percentage relative error. Very first class we are going to discuss in the regular class. Measured minus true. Vm minus Vt upon true. Right. Relative error is always expressed. Absolute error expressed in terms of true value is nothing but relative error. Please calculate. 1.48 minus 1.55 upon 1.55 into 100. Again direct question, yes or no? Again direct question from class notes only. Minus, this value is around minus 4.52, minus 4.52 percentage. Hence option C is the correct answer. Okay. Yeah. Next, go to the next question. Please tell me. Yeah, the measurement of a precision of instrument defines smallest change. What are they given? Smallest change in measured quantity that can be observed. Don't worry about precision word. Don't worry about precision word. What do you mean by resolution? The word resolution refers to certainty or smallest value of change in input quantity that we can detect with more clarityness or more certainty. It's nothing but, so resolution of the instrument, no need to explain more. Yes, fine. Consider the following statements. The cesium beam and hydrogen measure are the primary absolute standards, correct? The rubidium vapor standard is based on the hyperfine transition in rubidium 78 rubidium gas between states F equal 2 and F equal to 1. Absolutely correct. They are all basic definitions, right? It's important. Sometimes you may neglect these things. The secondary standard of an EMF is the unsaturated western cell, whose voltage is around 1.0183 volts. 1.0183 volts, whose approximate voltage. I think all statements are correct. 1, 2, 3. So hence option C is the correct answer. Okay. Yeah. Which one of the following statements is correct regarding standards of measurement? In our in our measurement system, we are having different types of standards. Those are defined by IBWM. What is IBWM? International Bureau of Weight Sign Measurement System, located in France. According to IBWM, international standards are more accurate and not available for ordinary people. Not available for ordinary people. Read it. They are also called primary standards. Primary standards as accurate and the international standards correct. Okay. Secondary standards are preserved at the International Bureau of Weight Sign Measurement System. But the statement, instead of secondary standards, they must use the word primary standard. Then only statement number 2. Then only statement number 2 is correct. But here, instead of primary word, they given the word secondary. Instead of primary, they given the word secondary. That is the reason. So it is wrong. Okay. Secondary standards are absolute standards, not as accurate. No, they are accurate only, but not accurate as international standards. Okay. Right. Working standards are used. Secondary standards are the absolute. It's not absolute. This is the wrong word. Understood? Secondary standard. Primary standards are absolute standards kept at international standard laboratories. Working standards are used by manufacturers. No, is used by common man in our daily life. That is the reason. Hence, which option is correct? The available option is option A is the correct answer. Okay, right. These are the questions available. Right. I hope that how you scored is all good. Hardly 2 or 3 questions are tough. Okay. Right. Thank you.
Hello students, good evening. So today we are discussing about the ESE 2022 prelims exam, solutions of analog and digital communication systems. So myself is Naveen Kumar. So we will see about the first question. So consider the following statements regarding the signals. Deterministic signal is a signal about which there is no uncertainty with respect to its value at any time. Already we studied about the two types of signals we are having. The first one is called as deterministic and second one is called as random signal. So deterministic signal is going to be always does not have any uncertainty, but random signal is always having some uncertainty. So because of that the statement 1 what we are having is absolutely correct. It's a correct statement. So see that he was asking which of the above statements are correct, he was asking. So which one is the correct statement is required for us. Now see, each signal within the ensemble has a certain probability of occurrence. So and the ensemble of signals is referred to as a random process. So ensembling means gathering of all those events and forming as probability of occurrence we are having, said to be called as a random process. This is also a correct statement we are having. So ESE signal is an example of an random signal. If you talk about the ESE signal, so ESE signal will tell us about the brain activity. That's talking about the brain activity. So how the brain was working, the functionality of ESE signal. If you talk about that signal, ESE signal, so there is also a random signal because the brain will going to be think about the thought process will changing, the functionality of the signal is going to be not constant all the time. It will changes with respect to the time also. That means a signal is said to be called as a random signal. It's also a correct statement. So D, that is 1, 2 and 3 are correct. So if you talk about ESE signal, the full form is called as electroencephalogram is the full form we are having. Okay. So talking about the next question. So which one of the following statements is not correct? Asking about which one is not correct he was asking. So if you see that is not correct. First one, the noise performance of a full AM receiver is always inferior to that of a DSBSC receiver. So if you see that the noise performance of AM receiver is always inferior when compared to DSBSC because the figure of merit of AM is less than 1, but the figure of merit of DSBSC is 1. So that's why it is the correct statement. So ask which is not correct. So this one is the correct statement. The figure of merit of DSBSC receiver using coherent detection is always unity. Yes, that is also correct. So figure of merit FOM is equal to 1 for DSBSC. So no need to write about that. So obviously we know that figure of merit of AM is given as the value is equal to mu square divided by 2 plus mu square. If you take the value of mu is equal to 1 and that is equal to 1 by 3 we are getting. So if you talk about the figure of merit of DSBSC and figure of merit of SSB-SC single sideband suppressed carrier is equal to 1. So which is going to be the first statement is correct, the second statement is correct, the third statement is also correct. The figure of merit of SSB receiver with coherent detection is always unity. It's also correct statement. So then the leftover one is the last one, the figure of merit of an AM receiver using envelope detection is always greater than unity. No, it is less than 1. So it's not always greater than 1, it is always less than 1 we are having. If you take the maximum value of mu is equal to 1 and the figure of merit was equal to 1 by 3. So this is going to be not a wrong statement. So out of all these options you can find out that option D is the answer. Why? Because means following statement is not correct he was asking. So 134 option D is the answer we are having. So coming to the next question. The RF carrier range and IF bandwidth corresponding to AM radio receiver are respectively. If you talk about the AM radio, if you see the AM radio, the specifications given by FCC, Federal Commission for Communication. So the first one is the frequency range we are having 535 kilohertz to 1605 kilohertz is the total range that we are having. That's RF carrier range we can have. That is the carrier frequencies, which is called as carrier frequencies also. We can equal to that of 535 kilohertz to 1605 kilohertz. And if you see the bandwidth, the signal bandwidth. So writing about the signal bandwidth is equal to that of 10 kilohertz, which is given as a standard bandwidth that is present in our AM radio receiver. If you see these two things, option which was matching is in terms of megahertz. If you convert kilohertz into megahertz, that is equal to C option. So 0.535 megahertz to 1.605 megahertz, and 10 kilohertz is the corresponding bandwidth, IF bandwidth we have. So the answer is equal to that of 135, equal to C we are having. If you see about the next question, that is the another question, question number 136. For the same average transmitted or modulated signal power and the same average noise power in the message bandwidth, a coherent SSB receiver will have exactly the same output signal to noise ratio as the SSB receiver we are having. That is, an SSB receiver is present. Is the question. Next one, over a certain binary communication channel, the symbol 0 is transmitted with probability 0.4 and 1 is transmitted with probability 0.6. So probability of solution for this one, probability of 0 is equal to 0.4 and the probability of 1 is equal to 0.6. It is given that probability of epsilon by 0 is equal to 10 to the power of minus 6. Probability of epsilon by 1 is given as 10 to the power of minus 4, where probability of epsilon by xi is the probability of detecting the error given that xi is transmitted. So what is the error probability of the channel? So if you see that P of epsilon by xi is the probability of detecting the error given that xi is transmitted. So what is the error probability of the channel he was asking. So if you talk about the error probability of the channel, so we can write that probability of error is equal to probability of 0 into probability of epsilon by 0, that is the probability of occurrence of error, so detecting the error, and probability of 1 into probability of epsilon by 1. So substituting the data, so probability of 0 is 0.4 into probability of epsilon by 0 is 10 to the power of minus 6 plus probability of 1 is equal to 0.6 into 10 to the power of minus 4. And if you are trying to solving this value, that is by solving, probability of E is equal to 0.604 into 10 to the power of minus 4 is the value we are having, that is P of E. So 0.604 10 to the power of minus 4, option D is the correct answer. That is the probability of error we are having. So option D is the correct answer we are having. So option D is the correct answer. So next question, another question. Which one of the following noises arises in electronic devices such as diodes and transistors because of the discrete nature of current flow? So obviously we studied such that different types of noises like internal noise and external noise. If you see the internal noise we study about the thermal noise, short noise, flicker noise, so transist time noise, partition noise, so mixer noise, right, all these noises we study in the classroom. And now if you see about that, due to the diodes and transistors, the noise that occurs is nothing but an short noise. So as we study in the classroom, it must be a short noise which will occur with respect to that of your the discrete flow of nature or switching devices will provide a noise called as short noise. So next question. So which one of the following represents the output signal to noise ratio of a uniform quantizer? Asking about uniform quantizer, where P denotes the average power of the message signal M of t and R denotes the number of bits per sample. So the R denotes the number of bits per sample he was given. So if you see the solution, so we know the SNR, signal to noise ratio. Your signal to noise ratio was going to be given by signal power to that of your so noise power. So we know that the signal power present is equal to that of P. So that is equal to P, it's not square, it's equal to P we are having. So divided by noise power, that's a uniform quantizer. So quantization noise power we can take. That is given as delta square by 12 and that is equal to P divided by delta square is equal to 2 AM. So which is also going to be written as maximum value of your message signal, that is given as, so m into maximum for the signal, so 2 into m into maxima, and that is equal to that of value is equal to L, right. So this entire thing will become as a square value we are going to be obtained. So that is written as so whole square, that is delta square upon 12 we are having. So then we can just substitute the value. If you just substitute the value, you can find out like this, that is equal to SNR is equal to P. So I forgot to write about the square here, that is delta square by 12, that is equal to that of 12 divided by 4 m square maxima into L square, and this will equal to 3 times, that is equal to 3p divided by m square maxima, and that is equal to L. We know that L is equal to 2 to the power of n, that n is given as r, therefore 2 to the power of 2r is the value we are having, and that is equal to that of option A is the correct answer. So that's the signal to noise ratio, asking for your uniform quantizer. So next question, removing the redundant information before encoding is the basic idea behind. If you see that we are trying to reducing the redundant information, so before performing the operation, it is said to be called as your differential pulse code modulation. If you see the differential pulse code modulation, what are the redundant information we are having, that can be removed off, and then we can going to make the quantization of the particular sample. So two samples to correlate to each other, so then we can remove the unwanted thing and we can send what is the required thing between the two samples. So obviously study in the classroom, that's the DPCM, differential pulse code modulation. So coming to the next one, so by seeing this we are going to be knowing about the circuit called as pre-emphasis filter. It's a pre-emphasis filter we are having. So answer for question number 141, it's a pre-emphasis filter we have. So next one is, in which one of the following techniques RF binary signals are transmitted as given. So bit 0 is given under root of 2p dash of t cos of omega c minus delta omega by 2 into t. So bit 1 is transmitted as root 2p dash of t cos of omega c plus delta omega by 2 into t. We observed one thing here, frequency is changing. If the frequency is changing for your binary bits 0 and 1, said to be called as frequency shift keying technique. Therefore, if you find out the answer is equal to that of B. So change in the frequency, this indicates a low frequency, this indicates a high frequency. We can write the same thing equal to that of this part as FL and this part as FH, which is given as your FSK, frequency shift keying technique. So coming to the next question, how many 6 MHz wide TV channels can be multiplexed on 800 MHz coaxial cable? So this is the 800 MHz coaxial cable is given. So solution. So we can talk about the number of TV channels to be present. Obviously we studied number of stations is nothing but an, we can given like this, equal to channel bandwidth by signal bandwidth after modulation. So the channel bandwidth is given as 800 MHz. So divided by your 6 MHz, then the answer is equal to 133. Of course 0.333 we will get, but it is equal to 133 number of TV channels can be accommodated. That 0.33 cannot be considered. So this is the answer. Option C is the answer we are having at 133. So coming to the next question. So statement 1. Shannon has shown that it is possible to achieve error-free communication by adding sufficient redundancy. Yes, definitely. The channel encoder will perform the same thing by adding some redundant information. Redundant bits are to be added. We call it as parity bits. So that parity bits are useful for our detection technique at our receiving side. That means make our transmission as an error-free transmission, whether error is present or not. And that is going to be the correct statement. So statement 1 is correct. The addition of an extra check digit increases redundancy. So addition of extra check digit increases the redundancy means it's not a correct statement we are having. So that means it's not a correct one. So we can tell clearly such that the assertioning and reasoning. So statement 1 is correct, but statement 2 is not true. So which is equal to that of 158th question. Answer is C. Okay. So thank you, students. Hello students, we will see about the ESE solutions for prelims exam done today. The solutions of advanced communication systems. So myself is Naveen Kumar. We will see about the questions. First question, the internet protocol IP is the heart of the TCP/IP protocol suite. IP corresponds to the network layer in the OSI reference model and provides. The first thing we study in the classroom is IP. Internet protocol is a connectionless oriented protocol. Okay, connectionless oriented protocol it is. Because of that, there is no virtual circuit. Virtual path is not present. Virtual circuit is not present. And one more important thing is it is always going to be provides the best effort delivery service. If you check the options, a connectionless service to the application layer which requires a virtual circuit. It's not a connectionless service to application layer, it's a connectionless service to transport layer. And there is no virtual circuit has to be present. High reliability in packet delivery, no, because of connectionless service, the reliability is not present. The reliability is very, very less. It is not having a good reliability. Next one is a connectionless best effort delivery service to the transport layer. It's a correct one. It's a correct one. So internet protocol, the correct one is they have connectionless it is, providing best effort delivery service to the transport layer. It is also connectionless here, but providing to the application layer. Okay. So next question, coming to the next question, the orbital satellites are, if we talk about the orbital satellites, so generally we see about the orbits, we find the equatorial orbit, polar orbit, inclined orbits. So most of the orbits we can find out are comes under the category of non-synchronous. To make them synchronous, we are trying to placing them in the equatorial orbit in a circular path called geostationary. So that's what non-synchronous. So next one, a question once it is asked from again the satellite. The requirement for reliability, long life, stability, high efficiency and suitable for space environment are met by the use of. We study about the space communication, mostly they use the microwave frequencies, and especially for the microwave frequencies in satellite communication we use the traveling wave tube. Your traveling wave tube was going to be the one which is provide the amplification, so called as traveling wave tube amplifier, will provide all these things, reliability, long life, stability, high efficiency and suitable for space environment is TWT, traveling wave tube. So next one, the highest frequency that is written to the earth at a given distance is called as. So if you see that the ionospheric layers, so D, E, F1 and F2, and when we are sending a signal reflected back to the earth surface between the transmitter and receiver is said to be called as the maximum usable frequency, MUF. It's called maximum usable frequency. So that to be called as MUF, maximum usable frequency we are having. Okay. So next one is the mean sun does move at a uniform speed but otherwise requires the same time as the real sun to complete one orbit of the earth. This time is nothing but a said to be called as the tropical year. The common thing, the mean sun does move at a uniform speed but otherwise requires the same time as the real sun to complete one orbit of the earth, and this time is being said to be called as the tropical year. Okay. Next one, which one of the following statements is not regarding SONET networks? Okay, synchronous optical networks, SONET was asking. A point-to-point network is normally made of an STS multiplexer. If you talk about the STS multiplexer, The definition is said to be called as synchronous transport signal multiplexer. Synchronous transport signal multiplexer. So SONET is asking not correct. See, check it. It's not correct. It was asking. So SONET can going to be a point-to-point network is normally made of an STS multiplexer we are having. It was the STS multiplexer. So it's a true. We can have a linear synchronous optical network can be point-to-point or multi-point. Yes. SONET can be point-to-point or SONET can be multi-point also. By using the couplers, we are going to distribute our same network to the different networks also. That means this is also be a correct. The signal flow can be unidirectional or bidirectional. So both in one way or in the two way, the signal can going to be transmitted. It can use for both simplex as well as duplex. That means the SONET, that means this optical network, synchronous optical network is both. So flow can be unidirectional or bidirectional. A multi-point network, see, we can have two types of networks are there. One is point-to-point, another one is multi-point. Point-to-point is always using STS, but multi-point is always going to be not using an STS multiplexers. This is not using an STS multiplexers. They are using add and drop multiplexers, ADM. They use ADM. ADM stands for add and drop multiplexer. So add and drop multiplexers are going to be used by the multi-point network in SONET networks. Okay, so that means this one is the wrong. That means which is not correct he was asking. So option is D. This is about the SONET networks we are having. So next one. So digital optical fiber communication system operating at a wavelength of 1 micrometer requires a maximum bit rate of 10 to the power of -9. What is the theoretical quantum limit? Quantum limit. And is asking the digital optical fiber communication system. So when you're talking about the quantum noise, we study about the two types. One with respect to analog communication system, other one is with respect to digital communication system. So when you talk with respect to the analog communication system, we consider it as a short noise, and we can going to be solve it with respect to the short noise. But when you use the digital communication system, we need to talk with respect to the Poisson distribution has to be considered, and need to solve with respect to the Poisson distribution only. So we're asking about theoretical quantum limit at the receiver in terms of the quantum efficiency of the detector and the energy of an incident photon. So energy of incident photon and the quantum efficiency. We know that quantum efficiency is equal to eta detector, and the energy of an incident photon is nothing but an h into f. So in that he was asking. So if you see the solution for this one, so we need to use the quantum efficiency. The solution for that one is, so we have to use the value called as probability of error is equal to exponential of z to the power of m. So e to the power of z to the power of z of m is nothing but an 10 to the power of -9. It is given 10 to the power of -9. Actually this value must be required for us. So P. Now when you talk about the Zm, the value of Zm is equal to, from this we will get Zm is equal to, the value is equal to 20.7 from this expression. So after writing about the Zm is equal to 20.7, so we need to write about the remaining values. That is, we know the Zm is equal to, so study in the classroom, efficiency P0 into tau divided by, so h into f. So E minimum is equal to P0 into tau, that is equal to Zm into h into f divided by efficiency. So E minimum, that is the theoretical quantum limit that we are going to be having, is nothing but an 20.7 h into f divided by quantum efficiency, and that is the answer which is equal to option A we are having. For question number 79, the answer is equal to option A. So this is the answer we are having. Okay. So next one we will see about the, with frequency reuse several cells with no space in a given coverage area, use the same set of frequencies. Two cells using the same set of frequencies are called as. Obviously, we know that there are two types of cells when you use frequency. One is adjacent channels, other one is called co-channels. So, using the same frequencies are called co-channels, using different frequencies are called adjacent cells. That means the answer is equal to co-channel cells. So, no need to explain here. So, direct question came from the notes. Okay. So, next one is the component in the satellite that takes an uplink signal and converts into a downlink signal is called as. So, if you talk about the satellite, it is very clear such that we are going to be having the uplink, and this is about your satellite. Your satellite was going to be consisting of the transponder, and this is about the downlink we are having. It is the transmitter, it is the receiver, and this is an uplink, and this is downlink. So, the one which converts your uplink to the downlink is nothing but it's a transponder. That is, the transponder is the correct answer we are having. That is option B. So, next one. An advantage of passive satellites is that they do not require sophisticated electronic equipment on board, although they are not necessary void of power. Some passive satellites require which one of the following for tracking and ranging purposes. So, even though we studied two types of satellites, one is active satellite, other one is passive satellite. So, passive satellite does not require any gain devices and does not require any onboard devices. But one thing is, for the satellite to perform the tracking, for the same passive satellite, not only reflecting back the signal, to perform tracking, so definitely we have to use a radio beacon transmitter. A radio beacon transmitter is used for providing the tracking and ranging purpose. For this purpose, we are going to be using a radio beacon transmitter is used. Okay. So, coming to the next question. Some of the diffracted light continues down the fiber and some of it escapes to the cladding. The light rays that escapes represents a loss in the light power, which is called as scattering loss. The scattering loss is called as Rayleigh scattering loss, because the light will be diffracted by the impurities that we are having. So, once it is going to be diffracted in all the directions, and we can going to be call it as the Rayleigh scattering loss is present. So, this is about 83rd question. So, next one is numerical aperture is closely related to acceptance angle and is the figure of merit commonly used to measure. Obviously, direct statement in the class also we study about that, the magnitude of the acceptance angle. It gives the magnitude of the acceptance angle. So, magnitude of acceptance angle was going to obtain with the numerical aperture. So, next one is which one of the following fibers has the distinct advantage of low intermodal dispersion. If you see the low intermodal dispersion obtained with SMSA fiber, the direct one, it is single mode step index fiber, SMSA fiber. So, single mode step index fiber is present. So, multimode fibers are definitely going to be having the more amount of intermodal dispersion is present. So, next one is which one of the following statements is not correct regarding the features of CDMA. So, asking about regarding the features of CDMA, he was asking multipath fading must be substantially increased because the signal is spread over a large spectrum. The first point I want to tell to you is not correct, he was asking. So, this is not correct, is not increased, it must be reduced, So, option A is the correct answer, so which is not a correct one because it is not increased, it will be reduced. Okay. So, next one. So, these are the questions we are having. So, which is said to be the questions for advanced communication system. So, this time they asked approximately 14 questions they asked for advanced communication systems. Okay. So, thank you. The next subject will be discussed by the other faculties. Thank you so much.
Hello students, there are many questions which are given in computer ordination and architecture. So, I am Vijay Kumar, let us continue the questions based on this subject. So, it has got very good weightage this time also as usual. So, let us discuss the questions. Myself and one more faculty, Balakrishna sir, would be discussing about the questions. So, let me complete a few questions, then sir will continue the questions. Right, look at question number 111. Which of the following basic steps are needed in order to perform a memory read operation? See, the important registers of a CPU are MAR, memory address register, MDR, program counter, instruction register. There are certain registers. So, whenever you want to read something from the memory, the register, any address of memory should pass through MAR only. For example, if I take a simple block diagram of the processor, let us say these are the registers. One is called as memory address register, other one is called as memory data register. For example, I want to bring some instruction into processor. Let us take the content of program counter. So, this is memory, right? So, in the memory at certain location, say this is memory, at certain location, say at 2000 H, there is some instruction I have to bring into the microprocessor, some instruction is there. So, the program counter which takes care of the address of next instruction, this is copied into MAR. Any address of memory or IO device should pass through memory address register. So, therefore, first this is copied here and this address is, this is the microprocessor, right? So, this address is placed on the address bus, certain location is selected, from there the instruction is brought into microprocessor. Any data from memory or anything that is present from the memory location that is brought into microprocessor into a register called as memory data register, then only it is copied to other register. For example, if it is instruction, it is brought into IR. It means that now to bring the data from memory to processor, it can be code or data, whatever it is, memory read. So, what is the sequence? First it is copied to MAR, then placed on the bus, and after that memory will take some time to release the data. Then it is brought into memory data register, then only to other registers. So, what is the sequence now? If you observe the sequence, what is the sequence? The first one is asking what is the sequence? The address of the location from which word is to be read is loaded into MAR. That is correct. First only, that is correct. Second one, a signal called read is issued by the process. So, to bring the data, for example, if it is a RAM, random access memory, read write memory, so you can read and also write. So, after pointing the address, read signal is transferred here. So, memory will release the data onto the data bus, then into the processor. So, therefore, a signal called read is issued, that is correct. Third one is corresponding memory delay, whatever the delay is there, after the data is brought into MDR, that is also correct. So, all the three are correct, means option is D. Right. Next one, which one of the following addressing modes is used to compute the address of the operand by adding a constant value to the content of register? First of all, what is the meaning of addressing mode? Addressing mode indicates a method by which you can understand how the data is brought for a particular instruction. So, data is present in the memory. How many methods you can bring the data into the instruction for operation, that is called as addressing mode. Okay, these are various formats specifying the operands, or in other words data, how to bring the data for a particular instruction. So, there are different addressing modes like direct, indirect, register, immediate, register relative, index. There are many type of addressing modes based on the microprocessors. Several processors will support different addressing modes, but all processors will not support all addressing modes. Okay, fine. So, if you observe here, first one is what is saying, which one of the following addressing mode is used to compute address of the operand by adding a constant value to the content of register. So, immediate addressing mode means data is present in the instruction. This is wrong. Next one, indexed addressing mode. So, in the indexed addressing mode only, the address is calculated by adding some constant value. For example, if you take PC relative or any other register which is a reference, some constant value can be added. That is called indexed addressing mode. Is it clear? Fine. Similarly, absolute direct addressing mode contains address of the data. So, there is no need to add anything. This is wrong. And absolute is same as direct addressing mode. This is also wrong. So, correct answer is indexed addressing mode. Which of the following statements is or are correct? So, always understand the question properly. He is asking which are correct, okay, for memory mapped IO. See, the IO devices can be identified in two ways. One, either IO mapped IO, other one is memory mapped IO. So, one is called as IO mapped IO, other one is called as memory mapped IO. One is IO mapped IO, other one is called as memory mapped IO. Fine. In IO mapped IO, every device has got a specific address. So IO, every device has got unique address, okay, 8-bit address. So here IO device will have 8-bit address, and here in memory mapped IO, IO will have 16-bit address. I hope you are able to understand. So what is the basic difference here? In IO mapped IO, huge amount of memory is available. It means the whole memory, for example, in a processor like 8085, it can handle maximum memory of 64 KB. This entire memory is used only for memory applications like storing the program, data, everything. So the IO devices will have a separate address, means 64K indicates, for example, say 0000 address to FFFF address. So these all addresses are meant only for memory locations, not for IO device. Means separate unique 8-bit address is given to the IO device. That is called as IO mapped IO, and instructions are also different. In and out are used. But in case of memory mapped IO, 16-bit address is given to IO device. It means the total 64K memory is divided into two parts. So this same memory address whichever is there 00 to FFF, this can be shared between the memory and the IO devices. Are you able to understand? Therefore, it means that in the memory mapped IO, the total 64 KB is divided into for both IO devices, or in other words say memory, and also for the IO device. It is divided into memory and also IO device. It means the IO device will also have same as memory address, 16-bit address only. It means in 64K address location, some addresses are meant for memory, some for IO device. It means memory space got reduced, no? Because the same memory address space is shared by both IO device and memory device. But the advantage here is that processor does not know that it is communicating with IO. It is same as address location. You can use all arithmetic and logical instructions with the instructions directly. So that is the advantage. So look at the options which are given here. The first one says the advantage of memory mapped IO is the ability to execute a number of memory dedicated instructions on registers in the IO device, in addition to the elimination of need of dedicated instructions. So what are the dedication instructions in normally IO mapped IO? The dedicated instructions are something like in and out. Okay, so this in and out instructions are not required here. So that is correct only. Second one, the disadvantage of memory mapped is that is the need to dedicate part of memory address space for IO device. So total 64 KB means this address space 00 to FFF is shared between memory and IO. It means the memory address space is reduced. Means among these total addresses, 65,536 addresses, some addresses are meant for memory and also for the IO device. That is correct only. So the answer is both 1 and 2. The option is D. Look at the next question. Which of the following addressing modes is similar to the register addressing mode in the sense that effective address of the operand is the content of register which is included in the instruction. So here if you observe carefully, just now in the previous question we have discussed what is the meaning of addressing mode. So here effective address means how the actual data address is calculated or ruled by different instructions. Okay, same thing. Where is the data's address? That is called as effective address. Fine. So therefore address can be present in instruction, that is called a direct addressing mode, and data can be a part of instruction, immediate. Data can be in between the registers, register addressing mode. So no data or operand is there, but some operation is performed implicit. There are several type of addressing modes. So here in the auto increment mode, auto decrement mode, you have to increment a register, then it is used as reference. Or auto decrement mode, the content of register is decremented first, then used as a reference. So here he is asking that in which addressing mode the content of register is included in this. So indirect addressing mode, it is equivalent to indirect addressing mode. So immediate means it will have data itself. This is wrong. So these two are simply like increment and decrement, then it is used as a reference. So here, so if you take both of them, then it's not possible. Therefore, the correct answer is relative addressing mode. So they resemble like indirect only, but it is incremented before and after. So it is first used as a reference, then incremented. It is first decremented, then used as a reference. So, but as compared to all the three, the correct option is relative, something like PC relative, because here the PC will have the memory reference where it has to bring. So like this can be called as relative addressing mode. So 114 is A. The next one, let us go for the next question. 116. In order to keep the track of the instruction locations, which one of the following contains the value of memory location assigned to the instructions or operand being processed? Now observe carefully. in order to keep track of instruction locations, see, instructions are present in the memory, so that some track should be put or kept inside the processor CPU. Who is taking care of that? He is asking. Very simple, think logically. Data is present in the instruction, okay, or operands are also present data or instructions are present in the memory. So there must be someone who is taking care of all these things, tracking of the addresses. Who is doing that? Look at this. LD is simply load instruction. STA, store activities, and what? To store the content to the memory. Load means from memory. These are instructions. End is also something like instruction, right? But here if you observe, this is called as something like instruction location counter, or ILC. It's a type of counter which will keep track of the instructions. So this must be the correct answer, because remaining three are simply instructions. They are not keeping track of instructions. So that is the correct answer, option D. So there is some counter which will take care of this one. Next one. Which of the following instructions are long and allow maximum parallelism since each bit controls a single control line? So this question is something linked up with the control unit design. So the control unit can be designed in several ways, like for example, it can be hardwired control, it can be microprogrammed control. In the microprogrammed control, there are two types again. One is called as, in the microprogrammed control unit, the instructions are called as micro instructions. There are two formats for this particular micro instructions. So one is called as the horizontal type, the horizontal micro instructions. I'm writing in shortcut, okay, micro instructions. The other one is called as vertical micro instructions. So what is the difference between these two basically? See, in the horizontal instructions, every control signal will be indicated as, every control signal will have one bit in the instruction format. That is what he is asking. It's a direct question. Okay, that's a very definition of horizontal micro instruction. Okay, so therefore what happens is that, for example, say this is the micro instruction format, so every bit indicates the control signal. For example, say there are some 6 control signals, so S0, S1, S2, S3, S4, S5, something like this, for example, say. So every bit is one control signal, so instruction length will increase, right? So but what is the advantage? You can generate the control signal very quickly. Means the control signals are present in the decoded form. That is the main thing, decoded form. Got it? Yeah. So it is simply, the question is simply given with respect to the horizontal. So in the next case, so this is the correct answer. So what is the next one? In the vertical instruction, what happens is the instructions are, the control signals are like encoded form. The control signals are encoded form. So what happens is, to decode the control signals, it will take a lot of time for the control unit. That is why here parallelism will be little bit less as compared to the horizontal. So the remaining all are wrong. So these are all irrelevant. There are no such type of jumbled instructions or diagonal micro instructions. Only two types are there. So in which horizontal will have every control signal as one bit in the format. That is correct. Next one. So what is the option here? Option A. Look at the remaining questions. Remaining questions will be discussed by other faculty. Balakrishna sir will try to complete the remaining instructions, remaining questions. Thank you so much for your patient listening.
Thank you, sir. So let's move on to the remaining questions of computer organization and architecture. Myself, Balakrishna Virala, right? So let's see the question here. Which one of the following function is not correct, for operating system? Now it means if you observe the operating system will make some kind of functions. It is having some responsibility related to, look at your first observe here, allocating storage and memory. Now remember, the basic main functionality of the operating system is, whenever you are creating any program, whenever you are executing any program, so you need to allocate some memory to the program, memory to your program. See, that is done by what? Operating system only. That is a functionality of the operating system. So that is a true statement. He is saying that not correct function. Remember that's a correct function, right? Allocating, memory and storage to your programs. And the second one is handling basic input-output operations. Yes, that is taken care by operating system. Like, maybe like, bringing any program data, from your secondary memory to main memory, taking care of all that, internally that is done by operating system functionality. And next, providing protected sharing of the computer among multiple applications. Yes, sir. Remember, protection and security is one of the main functionality of the operating system. Okay, protection and security is one of the main functionality of the operating system. Yes, that is done by that. And next he is saying that a quick execution of the instructions. See, remember, quick execution of the instructions, executing the instruction very quickly, that is not any responsibility of the operating system. That is related to the depending on the CPU speed, depending on the type of the CPU you are using. So that is not related to operating system. Operating system cannot do anything to execute your instruction quickly. So that is all related to hardware. Remember, that is not based on the operating system. So we'll go with the answer. Right answer is a D. D is the right answer. Okay, and the next question, let's move on to next one. Okay, so this is a direct question from the floating point number, floating point concept. If you are already studied floating point, if you observe here, the floating point number is said to be normalized if the leftmost bit of the mantissa is 1. Okay, so that is a direct statement. Simple concept. You study in the floating point. Because your floating point will be represent the mantissa and exponent. If you studied all that, so I think you can easily answer that. So right answer is A. And the next question, which we are going to discuss is so this is the question. Which one of the following tables generated in the pass 1? He clearly saying pass 1 has an entry for every symbol in the program that performs its function. See, he is actually talking about the assembler, which will convert your code into what? Machine level instructions. So in the pass 1, that is done in the symbol table. Symbol table. You can easily guess also. Right? He is saying that symbols in the pass 1, you recognize all the symbols in the symbol table. So that is the direct answer is the symbol table. And next one, the next question. Which one of the following is entity that can combine object modules may have resulted from the assembling multiple assembly modules separately? See, based on the question you can make a guess. He is saying that combining object modules. Modules in the sense, if you take about C language program, maybe like functions or maybe some methods. See, combining means that is done by the linker. When you are having multiple functions, multiple programs in your program, that will be combined with the help of what? Linker. So right answer is a linker here. See, compiler is having the different responsibility, interpreter is having the different responsibility, and loader is having different responsibility. So linker is the one which will combine all the modules of your program in order to perform the execution. Maybe after one after the other in a proper sequence. If you want to execute, that combining will be done by the linker. So we'll go with the answer C. C is the right answer. So these are the questions from computer organization and architecture, so from EC, from EC paper. So thank you so much. Thank you, Vijay sir. Thank you for patient listening. That's all from our side. Thank you.